Welcome back, everyone. This is Michael Gibbs. Can you let me know if you can hear me, please? Just leave a comment in the comment below that says I can hear you, or Cloud Architect, or something so that I know that you can hear me. Hi, K1. Can you hear me? Can everyone hear me? Okay, good morning, K1. Good morning, Balwinder. So happy to see you here. Just waiting to see if a few other people can let me know that they're there. King Kids, Rick, wonderful Jeannie, Balwinder, fantastic Theo. Okay, terrific. Now that I know that you guys can all hear me, what I'll do is I'm going to get started in about 30 seconds. I'm super excited to have you all back here today. Today we're going to be talking about some more things. We're going to begin our discussions with DNS and Route 53, and then we're going to talk about some load balancers, and then we're going to build upon what we've been building on for the last couple days. So welcome back. If you're new and you haven't been here for the first 3 days, that's okay. We've stored every one of these last videos in a playlist, so if you've not seen this before and you're still working on your Certified Solution Architect Professional, please go see the playlist. We'll leave the link in the description below so you can find the playlist to access these videos. For those of you that don't know me, my name is Michael Gibbs. I'm the founder and CEO of Go Cloud Architects. I've been working in tech now for well over 25 years, and I've loved every last minute of it. And I've been coaching or mentoring others to either get their first tech job, get promoted in their tech jobs, or build their cloud computing or network architecture or tech careers for over 2 decades. This week, we're in the process of doing a Certified Solution Architect Professional Free Bootcamp. The format today, in case you weren't here yesterday or the previous days, is as follows. We're going to present for anywhere between 10 to 20 minutes, typically around 20 minutes, and then we're going to have approximately 10 minutes of breaks. Chris from my team was going to be collecting and aggregating your questions so that I can answer them during the breaks, because it's going to be impossible for me to actually look at the questions and comments on the screen and actually still be able to present and do this. Just a lot of moving parts going on. So don't think I'm ignoring anyone's questions. You all matter to me, and we're super excited and happy to have you here. So today we're going to begin with discussing DNS, or the domain name system. So DNS, or the domain name system, is really about making IP addresses easier to understand. So we previously talked about, for every device to operate on a network, it needs to have its own IP address. And that's great. But how could you, as a person, remember all the different IP addresses that actually exist? Well, I couldn't. But I could remember a name. So when you start thinking about DNS, I like to think of DNS as an electronic phone book. Basically, you look up the name of a business and it gives you a phone number. Well, DNS, for the most part, does the same thing. It maps a name, a human name that we can understand, to an IP address that would be kind of challenging for us. So let's say, for example, I wanted to go to cisco.com. I could know the IP address and I could put that in my browser, the IP address and the port number, and things would work perfectly. Or I could go to www.cisco.com and let the DNS system translate Cisco, which is a name that's real easy for me to remember, to an IP address. And there's lots of reasons we're going to do this, from redundancy perspectives, performance perspectives, failover perspectives, tuning and optimization perspectives, and we'll talk about all the great things we can do with DNS. But understand first, before we begin any other content, that DNS is simply a means to map a name to an IP address, and there's lots of different policies. So architecturally, let's see what this looks like, and I'm going to show you a couple variations so you can actually see what's going on behind the scenes. In this particular environment, we've got a user that wants to go to Amazon. Now, if they know the IP address of Amazon, they could pop it into their browser. Well, they could, assuming there wasn't a content delivery network in there, but they could still get away with it if they knew the exact IP address. So what happens, you enter the address in your browser, then your computer does a DNS lookup, and I'm going to show you what it looks like. And then after that happens, what happens is your computer actually knows the IP address, so then your computer reaches out to it via the IP address. So that's, realistically speaking, what's going on. Now, if you're curious to see DNS mappings, what you can do is you can go to your computer, enter a command prompt or a terminal prompt based on whether you're on a Windows or a Linux system, and you can do an NS lookup. For example, you can do an NS lookup of www.amazon.com, which is a fully qualified domain name, and what you're going to notice is the following things. You're going to notice the names of my DNS servers, and note they're both 8.8.8.8, which just happens to be Google's DNS servers. You can also see that it's got a pound 53 next to it, which is the way they're indicating port 53, which is the TCP and UDP port used by DNS. And then you can actually see what's going on where the name servers provide an IP address to the CloudFront distribution, and you can see what that looks like over here. So naturalistically speaking, what DNS is it's mapping a name to an IP address. So now let's talk about the DNS system in depth. And we're going to talk about DNS long before we get to Route 53. Route 53 is the AWS implementation of DNS. And if you're going to work with DNS, you have to know what DNS is, not just Route 53. So we're going to give you a good understanding of DNS first before we go to Route 53. So let's look at it this way. When you've got a domain name, it's really based on three separate components. It's going to be a host name, a domain name, and a top-level domain. So what do I mean by that? Host name is the name of a system. Domain name is the name of your domain. And the top-level domain will be a .net, .com, .edu, .uk, or something like that. So what is this all going to look like? It could be test.gocloudarchitects.com. That would be a fully qualified domain name, meaning something that's got the host main domain name and the top-level domain. It also could be www.gocloudarchitects.com. Again, that's a fully qualified domain name. Why is it a fully qualified domain name? Because it includes all the elements, the host name, the domain name, and then the top-level domain. That's what goes into being a fully qualified domain name. So if you want to reach something, you need the fully qualified domain name. Otherwise, you won't actually be able to reach it via the IP address. So fully qualified domain name, host name, domain name, top-level domain. So now let's start working with the individual components of this. So what are the individual components of this? So let's begin with the top-level domain. Now the top-level domain is the most generic part of the name. It's the part that ends the name, .com, .net, .co, .uk. And all of these top-level domains are going to be controlled by ICANN, or the Internet Corporation for Assigned Names and Numbers. And what happens is these parties, these organizations, distribute the names, the domain names through the top-level domain. And we'll talk about how that actually works. But the top-level domains are the second highest level of the DNS hierarchy. And the DNS is hierarchical, and we'll show you exactly what that means. But the top-level domains come directly under the root domain, which we'll talk about shortly. The root domain is going to be the overarching structure that's going to contain all of the subdomains and every single folder that's going to belong to a website. So I'll show you exactly what we mean by that coming up soon. And there are many top-level domains that are used today. It used to be just .com, .org, but there's a lot more that are coming. And top-level domain servers are really a group of servers that are going to facilitate the generation of a website's IP address names. If there are none of these servers, DNS just wouldn't do things. So I'm going to draw you a map in a second and show you what the hierarchy actually looks like. We're just getting through the little bit of the academic part first. So when we're talking about DNS, we start breaking things into zones. And what are these these zones? These zones are basically separately managed DNS spaces. So you can have a much more authoritative and more finely grained control of different components of your DNS system by using zones. Now this doesn't mean that a zone necessarily has to be geographically isolated, but they just need to be logically separated for different degrees of the control, especially with regards to delegation. And the ties to the top-level domain space is a hierarchical system within the root domain situated at the top. Okay, what does all this mean? Whenever I get into those deep technical weeds, like that, and there's a whole bunch of technical mumbo-jumbo, what does it really mean? Here's what it means. At the top level of the DNS hierarchy, you've got a root domain. Underneath the root domain, you've got top-level domains like .com, .net, .edu. I'm glad we got rid of all the academia out of this, so now we can talk about something that makes more sense. Then behind that, we're going to have the second level domain, which is going to be your domain name. And the third level domain would be like a subdomain. Drive.google.com, mail.google.com, training.gocloudarchitects.com. It's a subdomain, which is just a hierarchy in the domain. That's what I was talking about, creating zones, and it's just a matter of adding some hierarchy, adding some partitions, and logically separating them. Now, when we're talking about DNS, we're really talking about a registry. So first is really a database. So think of the database of your top-level domains and everything that's associated with it. Now, there are organizations that actually manage these. And what I mean by that is they give out these top-level domains. And the people that manage these top-level domains, typically speaking, is like VeriSign. They're one of the people in the domain registry that manage top-level domains. And of course, these organizations, turn in all of the domains that they're assigning back to ICANN, as we talked about, the Internet Corporation for Assigned Names and Numbers. They're really the people that are responsible at the high level of the system. So everything's coming from ICANN. They define the policies for the names and then the numbers. So when you're dealing with, you've got a registry, which is simply the database that contains the names. So the next thing that you have, so you've got a registry, which is all the name. And the next thing you have is a registrar. A registrar is where a business goes to actually register the domain name. Somebody like GoDaddy, for example, you go to GoDaddy and you register your domain name. They are considered domain name registrars. The registry is the list of everybody included. So if you go to GoDaddy to register your domain name, what are you? The person that's registering the domain after you receive your domain. Then you become called the registrant. I didn't make up these terms. I wish I did, because they're a little bit on the complicated side, but I didn't make up these terms. So a domain name registrant is the end user who basically registers the domain. So when I registered www.gocloudarchitects.com, I was the registrant. When I went to Ionis or GoDaddy or whoever I used to register my domain name, they were the registrant, and they all pull their information from the domain name registry. Some examples include VeriSign. So let's talk about what this actually looks like, again, visually, because when I start talking about registrar, registrant, registry, it feels kind of ugly to me. So you've got a domain registry at the top. Then there's these domain registrars. These are the people that a business purchases their domain names first. They're in blue. And then basically the registrant is the business who purchases the domain. That's it. That's the registrant. Registry at the top, registrar in the middle, registrant at the bottom. I wish this wasn't so complicated. I didn't make up these terms, so understand that we're going to try and make it as easy as we possibly can for you. Now let's look at it this way. Well, since we're going to talk about DNS, and DNS basically maps names to IP addresses, there's the way this happens is there are different types of DNS records. So we'll talk about the way these DNS records, again, this is some dry stuff. My apologies. I'm doing the best I can to try and make it as interesting as it can be. But DNS is just not one of the more fun things in life. So let's realistically see what's going on with these DNS records. So you can create a record, and each record that you're going to create, realistically speaking, is going to be something that maps a certain thing to a certain thing. And there's certain DNS records that are really, really important, and others that are not necessarily so important for you to know, but they serve other purposes, and we'll cover all of those. What you need to know versus what you don't need to know right now. Understand when you trace a record, it's got something called the time to live, and what the time to live really specifies is how long the record will actually stay active. Meaning, if I update the record, it's going to take time to propagate through all the services until they all time out based upon the time to live. So in anything, whenever you're setting a time to live, the shorter the time to live, the more work on the system. The longer the time to live, the less work on the system, but the more likelihood you might have some stale data. So realistically speaking, that's what we'd be referring to. So going past here, let's talk about AWS Route 53. Route 53 is the AWS implementation of DNS. Route 53 is a highly scalable platform for DNS services. What makes it scalable? It uses something called anycast, and that provides low latency, high availability, and health checks. Anycast is one of these really ugly concepts to talk about, but it's pretty important for high availability, so we're going to talk about anycast. I previously told you that every device on the network needs to have a unique IP address. I told you that because if I want to communicate with Chris on my team, I need to know his address. If I don't know his address, I can't communicate with Chris on my team. It's not possible. Now, there's a concept of anycast which basically violates the rules of everything having a unique IP address. And what anycast is you have multiple hosts that all answer to the same IP address. Why would anybody in the world do this? First and foremost, if you have a DNS server every 50 miles and they all answer to the same IP address, your routers are going to send you to whatever, typically speaking, whatever the lowest cost is of your DNS server. And because you get to the closest one, you're going to have the reduced latency. And if your local DNS server were to fail, what would actually go on is you'd go to the next farthest ones because your routers would send you to the next best path. So the only way anycast works is when you're only pulling information from these servers, and it doesn't matter which one you receive because they all have identical information stored on them. So for example, if you do an NS lookup on your computer and you type NS lookup www.cisco.com, chances are you might be using Google's DNS servers, which all answer to the address 8.8.8.8. Why is this? Because Google anycasts their things just like AWS anycasts their things. So think about a DNS server in New York and a DNS server in San Francisco and a DNS server in London. Here I am sitting in Florida. My closest DNS server is New York. It's 8.8.8.8. But it's not there, so my routers route me to the next closest one, which is going to be in California. If that doesn't work, my routers route me to the next 8.8.8.8, which is going to be sitting in London, and so on and so forth. This is the way anycast works. It's not for traditional communication. It's to promote performance and scalability. It's used in IP multicast and it's used in DNS. Now, I told you that there are certain DNS records that are necessary to know, both for your exams as well as your career. The key records to know for your exams are as follows. An A record is quite simply just mapping a name to an IP address, and we're going to talk about that more, but you must know this. We'll talk about a quad A record, which is like an A record but for IPv6. We're then going to talk about CNAME records and what they're used for, because that's a pretty important record for you need to know. We'll talk about an MX record because it's absolutely critical. We'll probably talk about a start of authority record, and then we're going to move on. So I just want you to know these are the kind of records that you should know. Route 53 supports all of these, but these are the key records to know. And we're going to talk about each one of these records and what they actually mean, especially for your design as well as your career. So the first record to talk about is the A record or the AAAA record. They're the same thing, but an A record is for IPv4 and an AAAA record is for IPv6. This is the most fundamental of all DNS records. This is the simplest. This is what people typically think of with regards to DNS, where basically this IP address maps to this DNS name. It's realistically speaking all it is. It's a record that maps a name to an IP address. The next record that gets pretty complicated, or is pretty common, is a record that maps a domain to another domain. So, for example, we are Go Cloud Architects, www.gocloudarchitects.com. But I've worked with some executives from Cisco, and then we've created some leadership programs. I've got some data scientists creating some data science programs for cloud computing. I've got some other cloud computing programs in development with some people that all have 25 to 50 years experience that are truly amazing, that are putting these things together with me. I'm going to be Go Cloud Careers. So I could create a CNAME record that could take everybody and map them from Go Cloud Architects to Go Cloud Careers if I choose to do that. Why would I do that? I've got lots of people that come to the Go Cloud Architects page every single day. I don't want to lose those users by going to Go Cloud Careers, but I might have a new website that is more reflective of the business. So as an organization, many organizations change the name of their website or something like that, and they use a CNAME record. Or a business buys another business, say Cisco buys another company, and they want to redirect it to the Cisco site because they're now a Cisco company. That's what a C record is, so a CNAME record. So an A record maps a name to an IP address for IPv4. An AAAA record maps a name to an IP address for IPv6. A CNAME record basically maps a domain to another domain. Can also map a CNAME record to an A record, but that's another story. Now let's talk about the next ones that really matter. The next thing is an NS record. And an NS record or a name server record is absolutely important, and that's going to identify the DNS servers that are going to be responsible for your DNS zone. The authoritative ones. You need to know who these things are. These authoritative name servers are going to propagate your organization's official DNS across the internet. And these can be several entities. So your NS record and your name server record, absolutely critical to know because that identifies the name servers that are going to be responsible for your domain. So A record, map the name to an IP address. AAA record does the same thing for IPv6. CNAME basically map a domain to another domain, and an NS record, basically what you're doing is you're identifying the name servers that are responsible for your domain. Now, if you're working for an organization that tends to basically have the ability to send and receive emails, then you're going to need something called an MX record, which is a mail exchange record. What is an MX record? It's what's necessary for you to accept mail. And because an MX record is necessary for you to accept mail, that's what an MX record is. The next record we need to talk about is something called the start of authority. What is the start record? It's the primary name server for the domain. It lists who's the responsible party for the domain. It's got a timestamp that changes whenever you update your domain. And it's really the number of seconds before your zone is going to be refreshed. So this is realistically speaking what goes into this. So now that we're going to talk about this, and we've talked about DNS, what it is, how it works for the most part, and why you would use it, now let's bring it back to AWS. See, the concept of just knowing the name of a service without knowing why, it doesn't do anything. But if you know why, then you can implement the cloud services. So let's talk about the cloud services that actually exist. And the first thing that I will talk about is Route 53, which is the highly scalable DNS provided by AWS. And it's really designed to give users a low-cost method for basically DNS. And because it's a full DNS system, it's going to work with IPv4, IPv6. If you're looking at Route 53 and you're wondering where they got the name, think port 53, TCP port and UDP port 53 are the ports for DNS. And what's great about Route 53 is, being any DNS provider, you can use it for both inside the AWS cloud and outside the AWS cloud. And Route 53, like others, enables you to do health checks, which basically means you can basically route your traffic with a policy. So maybe if one site's not there, go to another site. And we'll talk about the policies that can be based upon health checks. But health checks can dramatically improve the availability and performance of your systems by making sure that you don't send data to sites that don't exist. Route 53 is also a domain registrar, and that means you can just basically buy your domains from them. So you can register your domain name with Route 53, or you can transfer your domain name to Route 53. Either way, you've got the option. And if you purchase a new domain with Route 53, the good news is the systems will automatically configure a hosted zone for each domain, so it removes some of the complexity out of it for you. One benefit of using Route 53 is you get the privacy protection from your WHOIS record. So what that means is if you don't know this, because you've not worked with it, if you don't get privacy protection, everybody can know the name and phone number of the person that kind of registered for the domain. And if you're with AWS, it's convenient because this just gets added to the single bill you get by the end of the month. And Route 53 can use 150 top-level domains. So it's a pretty sophisticated DNS system. This is something where the cloud service isn't weaker. It's the same, if not better, in a lot of ways. Like I mentioned, you can transfer the domain to Route 53 from one account to another account. In order to do this, there's going to be some prerequisites to transferring domains, which are specific depending upon when you're transferring from. When you get involved in domain transfers, there's always a little bit of wiggle room and a little bit of challenges to think about. You typically speaking, have to have a registered domain at least 60 days ago to be able to transfer a domain. So you make a domain, and this is common with lots of service providers. You want to transfer it, you need 60 days. And if you're going to transfer a domain to Route 53, there's a few things that you can't do or you can't have in there. You can't have a client transfer prohibited on your domain name. It can't have a pending delete going on. You can't have a pending transfer going on. It can't have a redemption period there. And it can't have a server transfer prohibitive in the message types of things that are forbidden. So keep that in mind. It's not going to happen with you very often. There's only a few providers that actually make things that don't enable you to transfer your domains. But just keep that in mind. Now we're going to talk about hosted zones. A hosted zone is a concept in Route 53, and it's basically the same as a DNS zone file. So if you're used to creating a DNS zone file, basically that's what it's called, a hosted zone in AWS. And it's really just a collection of records that for simplicity can be managed together, belonging to a single parent domain. So what's going on is all the resources and record sets in the hosted domain must basically have the hosted domain suffix. Name is a suffix, so you can figure what that is, .com, .net, .edu. So for example, Go Cloud Architect's hosted zone records may contain something like www.gocloudarchitects.com and training.gocloudarchitects.com, but it wouldn't include something, say, like gocloudarchitects.net. So now what we're going to do is we're going to actually talk about some of the policies that you can use with Route 53. And when you're using these policies with Route 53, you've got a lot of options and you really need to know what they are. The policies we're going to talk about for routing with Route 53 are as follows. Simple routing, weighted routing, latency-based routing, failover routing. We'll talk about geolocation routing, multi-value answer routing, and geo-proximity routing. Now, some of these are going to make a lot of sense to you. Some of them are going to feel kind of, why would somebody do that? So we're going to talk about these things at the same time. So simple routing is basically the most basic routing. Map a name to an IP address. Simple, simple, simple to use. So go Cloud Architects, Route 53, and it knows exactly where to send it because it's got a simple mapping. Simple, 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 elegant, nothing complicated to think about here. The next kind of policy you could set with DNS, which is still kind of cool, is something called weighted routing. And what is weighted routing? Weighted routing is you can set a policy to basically send a percentage of your traffic to one location and another percentage of your traffic for another location. So let's think about this from the perspective of software release pipelines. Let's say you've got new software and you want to send 10 or 15% of your users to the new software, new site, and the rest, 85 or 90%, to the old one. That way you can test your software, see if the rollout worked to a subset of your users, and if it worked good, migrate your DNS for everybody, and if not, back off and bring it back to the known good configuration. This way you can test things with a small subset of your population without causing any major outages. That's when you use weighted routing. Send 80% to one thing, 20% somewhere else. It could be a good way you could offload data center to the cloud. You can set up a percentage in certain locations, manually configured, and you send a percentage to one case and another case. It's called weighted routing. So simple routing maps a name to an address. Weighted routing, 20% goes here, 20% goes here, 60% goes here. You specify the policy. Now this is kind of cool, latency-based routing. So when it comes to the user experience on the internet, how long it takes to get to a response and get a message back, that has a lot to do with how well people feel about their experience and their success in it based upon their experience. So latency-based routing will basically look at you and determine the amount of latency it takes for you to go from point A to point B. And by doing that, what it's going to do is it's going to help you find the closest web server in your DNS rotation that's going to give you the best performance. So that's latency-based routing. So for example, I go to the page. I'm near Palm Beach, Florida. You would think the closest web server might be Miami, or it could be Tampa. So what will happen is when I go and try and do something, it's going to look at the latency. Even though Miami is closer to me than Tampa, Tampa may have lower latency. And if that's the case, I'm going to be shifted to Tampa because it's the lowest latency. Latency-based routing is designed to send you to where it's most convenient, best experience because it's lowest latency. Highly interested, so look at it this way. Simple, name to an IP address. Weighted, split your percentage of your traffic. Latency, go to the site with that's fastest for you to get to and fastest to get your data back to get the best experience. It's a great policy, especially if you've got servers and data centers all over. Now look about failover. Failovers are a little different. Failover routing basically does this. You have two locations and you run what's called a health check. A health check is basically a message that says, are you there? Are you there? Are you there? And as long as the server keeps responding, I'm here, I'm here, I'm here, the server passed the health check, in which case data gets sent to the servers. Now, if the question came, are you there? And there was no response to the health check, that means there's a problem. That basically means DNS will know to remove this bad servers from the rotation and all of the data will be sent to a different location. So you set up a manual policy, send it to the New York office first. If the New York office isn't available, send it to San Francisco. Failover improves redundancy. It is a fantastic policy. It is a really great way for disaster recovery. Think if you had, for example, an application hosted in your data center and you wanted to do disaster recovery in the cloud, failover routing would do all of this for you in a perfect, elegant, smooth sort of way. So keep that in mind. Now we'll talk about the next one, which is geolocation routing policy. And this is actually pretty neat if you actually think about it. Geolocation routing, what it's going to do is it's going to route the user to the website that's closest geographically. And how does this work? Basically speaking, it looks at the source IP address of where you're coming from, and it determines where the closest place to send you is. Here's where this gets interesting. Let's say, for example, you're in an environment where there's multiple languages. By using geolocation routing, you could effectively send people to the right language. Let's say we were to come up with a set of web servers in Africa. Certain countries speak Arabic, certain countries speak French, and certain countries speak English. With geolocation routing, we could see where the person was coming from and send them to the right website based upon the language of their choice. Could do the same thing, have a web server in London. The London web server could basically support the French-speaking people in Europe, Spanish-speaking people in Europe, German-speaking people in Europe. Send them literally to the right web page based upon their source address because we know where they're coming from. That's pretty neat. So geolocation gives you the ability to optimize an incredibly good experience for the user. Send them to what's closest, but also send it to something that's relevant for them. So that's something I can see you using a lot in certain environments. I definitely have. Now the last one that we'll talk about here, actually we'll talk about one more, but it's going to be on the unique side, so we're not going to spend a lot of time talking about it, is the multi-value answer routing policy. And what is this? This is basically a combination of simple routing and random routing. You got a bunch of servers, and basically you just set up DNS to go to a bunch of servers, and basically it'll pick whatever it thinks is going to be the least used server at the time. And basically it's random, so it will share the loads, but it's not based on anything specific. I'm not a big fan for randomness in anything I design. I want some control over it, so this isn't something I've ever used in my career. Now, the last one that we'll actually talk about is something called geo-proximity routing. And geo-proximity routing, basically what happens is Amazon will route your traffic to resources based upon the geographic region of your users and you. So what'll happen is you'll determine what your geographic area is, and you'll increase or decrease the size of the regions through something called bias. And that's a way to get people to a geographically response. So you can look at, what the map looks like with Amazon. You can change the bias and you can shrink or expand these regions, but that's realistically speaking what's going on. A couple more things to talk about. With Route 53, they have the concept of a resolver, and the Route 53 resolver is basically the equivalent of Route 53 for your on-premises environment. So if you're using Route 53 and you want it to actually work for your organization, that's where you're going to use a resolver. So if you're using a hybrid cloud where you've got the network connected to a data center, this is where the Route 53 resolver comes in, and that way your data center can use the DNS of your cloud provider. Talk one last thing about health checks, and then what we'll do is we'll do some question and answer things, and then we'll get into load balancers, which is always a cool topic. So health checks are going to be there, and I mentioned previously, you're going to have your DNS service, and they're going to send a message, are you there, are you there, are you there, are you there? And then ultimately what will happen is either they get a response back, which is yes, and it stays alive, or they don't get a response back, and it goes away. So good response, server still there, check mark, bad response, X, web server's not there. Now you know how the health checks actually work, and we can do this. Now, I have not been paying attention to the questions. I don't know if there's any questions. I will wait and see if there's any questions. I've been told by my team that I should post a link to the training and what we do. So I will post a link to our Cloud Architect Career Development Program, which I'm always happy to answer questions on. And then I will post a coupon code to make it cheaper if anybody desires to become a Cloud Architect and is interested in Cloud Architect training. And what I'll also do at this point is open it up for questions. We have 10 minutes for questions. Does anybody have any questions on Route 53 or DNS? If anybody has some questions on Route 53 or DNS, please let me know. And I'd like to do anything I can to help answer them before we move to the next topic. How does DNS measure latency? Latency is typically measured in milliseconds. And you send a message and you get a message back. Most things use ICMP, but when you send a message, you can see how long it takes for you to get back, and that's how you can measure latency. What's the next question? I see some new names on this call, which is always exciting to see new folks. I don't remember seeing you in Finchy Hoke before, so welcome. We're happy to have you. And Theo Q, I don't remember your name, so I'm super happy to see you here. King Kids, I haven't seen you in the first couple days, so welcome, and I'm super happy to see you there. And yes, realistically speaking, a lot of these DNS services have a tremendous amount in common. Now, bachelors, you're getting into some DNS complexity. Realistically speaking, you've got a couple options with regards to DNS. So if you're going to use AWS for your Route 53, I would probably do it all with one single DNS provider, or else you're dealing with multiple zones and it gets really, really, really ugly. So I would probably either use Route 53 for your DNS, or I would use somebody like GoDaddy for your DNS. But I would pick a DNS provider whenever possible and try and manage it all through a single one. Okay, looking through these. Because actually we spoke a lot about inbound and outbound endpoints yesterday, like literally for about an hour. So if you were there yesterday, let me know. We'll further go to it. If not, please go back to yesterday's questions on endpoints. We spent at least an hour discussing them. So, Arif, we're going to cover load balancers next. Load balancers and Route 53 are completely different technologies, but we're going to get there next. Okay, so pistol grips log. Yeah, okay, well, actually, and then Ian, what a great question. So, PistolVix log, when you design an architecture, would you implement the policies? Realistically speaking, that's a great question. So, PistolVix log, if I had a simple website in one location, I would quite simply use simple routing policy. If I had a primary and a backup site, and my primary was active and my backup site I didn't want to send traffic to, then what I would actually do would be I'd use failover routing. If I was in an environment where I had to be concerned with where my users were coming from to put things in the right language, I would use geolocation. I would use this, for example, in the Middle East, where you might be speaking Farsi, Hebrew, or Arabic. I would use it in parts of Africa, for example, where you've got French, you've got Arabic, and you've got English, all as common languages in addition to other languages. That's where I would use one of these geolocation kind of routing policies, and that way you can send people to the language that matters most. I would also use that in Europe, where you've got lots of different countries that speak lots of different languages. And I would use weighted routing, for example, with software release cycles like blue-green deployments, where I would send 10% of my traffic to a test site and then 90% somewhere else. And that's, realistically speaking, the types of policies that I've used throughout my career and most people tend to use. So, actually, Ian Corner, what a great question. So I would have told you a year ago that if you cared about security, you could not use Route 53 at all. And for the longest time, all of those of us that were working in information security on cloud computing, when we looked at Route 53, we said not an option. And here's the thing, Route 53 until about a year ago, or even 6 months ago, did not support something called DNSSEC. And what DNSSEC does is it prevents something called a man-in-the-middle attack. So let's look at it this way. And so Joshua, it actually starts today, and I'll get to your question next. So in cloud, so what do I mean by DNS security? So what's actually going on is, let's say you actually have a source and a destination, and Mike is talking to Chris. I'm trying to find this in a place. So if Mike here is talking to Chris over here, all is good, because I'm expecting to be speaking to Chris from my team. Chris knows a lot about what's going on in the inner workings of my business because he's part of it. He's joining my team, and because of that, he knows a lot about my business. So I might say things to Chris that I wouldn't be willing to say to Joe. And if Joe pretends to be Chris, and I think I'm talking to Chris, but I'm talking to Joe, Joe could actually really hurt me. That's called a man-in-the-middle attack. So until DNSSEC became possible with AWS back in December, it would be impossible to create a secure environment with AWS. But thankfully, AWS implemented DNSSEC, and DNSSEC, basically speaking, prevents man-in-the-middle attacks. Then, realistically speaking, that's why you can do higher security architectures. So if you care at all about security, adding DNSSEC to your routing policy is always a good thing. And because after that, if you go through yesterday's and you have any questions, please feel free to reach out to us. So Joshua, GBE, Joshua, let me ask you a question. When is the Cloud Architect training starting? We take them on a rolling invention. Actually, today is a very special day for us in our Cloud Architect training. Students that sign up at some point today will actually be invited to our call at 3 p.m., which is our treat. We always have a call. So we have live calls on Monday and we have live calls on Friday. Today in our live call, we actually have one of the directors who's a hiring manager at AWS on our call. They're looking to recruit some people from our team. The reason they're going to be on our call, they want to talk to our students about what they desire in cloud architects, and they want to talk about the importance of soft skills, emotional intelligence, executive presence, and all those things. That's the difference between a cloud architect and a cloud engineer. It's impossible to get a cloud architect job without focusing on these things. That's why we focus so heavily on these things. But we will have AWS hiring managers on our calls because they like what we do with regards to the way we train architecture versus implementation. And they also like the way we talk about how to present, how to write, and do all these things because that's part of the cloud architect career. So the next time people are actually joining is now. We bring people into the program, and I don't want to talk too much about our program because I want to keep this training related. We bring people in our program on a rolling basis, and we pair junior people with senior people to work together. By doing that, junior people get to learn from the more senior people. Bonds and relationships are found, but also one of the most critical things to do as a cloud architect is be able to explain highly complicated technologies to people that don't know better. For example, you might have to present to the CEO, actually you will, the CFO, the CIO, the CTO, and none of them are going to really know that much about the tech. But you have to be able to explain it in a manner that makes sense to them, and you have to be able to ask the right questions in order to be able to design the solution that's going to meet the business needs. So we focus so much on that because I've been an architect now for almost 25 years, and I know the role, and it's customer facing, it's executive facing, it's writing, it's presenting, it's designing tech, and it's a parity, and it has a career potential growth like this. But those are the required skills. So actually it starts right now. If you're curious, you can direct any questions to Chris, who's a member of my team, in the window while I'm presenting. If you've got more questions, I will do like my team always tells me. I will post a link to the training as well as a coupon code for it, and I will go back to presenting. Do we have more questions before we go back to the content? Because I'm ready to go to load balancers, but we have about 2 more minutes if anybody has any questions before we go back to content. While we're waiting for new questions to come in, if you actually like the video, if you don't mind leaving a like or sharing this video with others that you think could be helpful, we're always happy to. Richard Webster, how long can it take if the person can invest about 2 hours a day? Well, there's approximately 250 hours of training on our course, Richard. That's what it takes to really turn someone into a real cloud architect and give them a great career. You know, a 10-hour certification training is about 10% of it, but the other 90% goes. So it's about 250 hours. For people that can invest about 2 hours a day, we typically say about 16 weeks is what it takes to get through to have them highly successful. Could take 20 weeks, could take a little less based upon how fast you learn, but I would say 16 weeks is on average for people that can spend 10 hours a week doing the studying, plus attending the 2-3-hour sessions in class. Any more questions before I go back? Okay, well, if there's no more questions, what I'm going to do is I'm going to go back to the content, and we'll basically present for 20 minutes, go back to questions, and we'll do anything we can to try and make some of these things as least dry as possible. So let's talk about load balancers. Load balancers are one of these really cool technologies, and load balancers are a device that's going to distribute network and application traffic. Here's the thing. Organizations use load balancers for the following reasons: improve availability and improve system performance. That's exactly how you do things. Improve availability and you improve system performance. This is exactly why you use a load balancer. So how does it do these kind of things? How does it improve availability? How does it improve performance? Why does Mike love load balancers so much? Well, for the following reasons. I've been designing 5 nines available networks forever. 5 nines available networks means 5 minutes and 25 seconds of downtime per year. That's it. And if you think you can achieve that with a single server, you can't. If you think you can achieve it with a single network connection, you can't. Look at it this way. If you have to upgrade Windows, that takes far more than 5 minutes. So now you need to think about what is, realistically speaking, 5 nines, how do you get there, and the types of operating systems and applications that can help you do it. So a load balancer is going to be a device that's going to send your network traffic or application traffic across multiple systems. By sending it across multiple systems, it's going to remove your single points of failure. So because of that, it increases availability. Now, we talked about improving performance, and I said you can scale up or you can scale out. Scaling up is using the biggest servers you can. Scaling out is adding additional servers as needed. If you had the opportunity to have a 128-core server with 4 terabytes of RAM, or 2 servers with 2 terabytes of RAM and 64 cores, you have a higher availability environment with the 2 servers than the one, because if one fails, you still got something. So typically think about it this way. That's why you're using a load balancer. But what if you needed 50 128-core servers? No big deal. You use a couple of load balancers and you share the load across the servers. So load balancers basically improve performance and availability by removing single points of failure. So when we're dealing with load balancers, there's really only 2 kinds of load balancers. Now, AWS is going to define 3, and we'll talk about it, but there's only 2 kinds of load balancers for the most part. There's network load balancers and there's application load balancers, and they're different. A network load balancer operates at layer 4 of the OSI model, basically TCP or UDP. And network load balancers are fast, super high performance devices. Network load balancers are really cool. Now, application load balancers are different. They're more intelligent. They look at things in the header of the message. They operate at layer 7, HTTP or HTTPS. And because of that, they have a lot more intelligence. When you have more intelligence, it slows things down. So for extreme speed and performance, network load balancer. For routing between microservices and more intelligence, typically an application load balancer. So that's how you can think about these things. Now, in the context of AWS, they call 3 kinds, but really it's just 2 kinds. They have an elastic load balancer, which is the name of their network load balancer. They have an elastic load balancer for an application load balancer. And then they have something they call a classic load balancer, which is just either a network or an application load balancer. So still falls into the category of network or application load balancer. They just have a bunch of different names for different services, and that can make it complicated, so we're going to try and make it simple. So the way this works is your elastic load balancer or your load balancers, you're basically going to distribute your traffic between multiple sources. And by doing it, again, it's going to improve performance. Now, elastic load balancers auto-scale themselves, and why? No load balancer can ultimately handle the loads of lots of things. If you've got 128 core servers, you're going to need a lot of load balancers, because the load balancer is basically a server that's going to share load between servers. So you need to make sure you've got enough load balancers. Now, in the context of AWS, you're dealing with load balancers that are redundant. So you don't necessarily have to build in your redundancy because they're automatically redundant. If you're not dealing with AWS load balancers, for example, and you're using like an industrial load balancer software on an EC2 instance, you're going to have to work for redundancy. So elastic load balancers, the AWS implementation ones, realistically speaking, are auto-scaling and they're highly available. And elastic load balancers can balance across zones, but they're going to support health checks, which we're going to show you. And we talked about a little bit with DNS. And they can also terminate SSL connections. So this is really cool. So what does that really mean? So by using health checks, and we'll walk through it again, but what's going to happen is the load balancer is going to say to the server, are you there? And the server is going to say, yes, I'm here. And it's going to go to the next server, are you there? And it's going to say, yes, I'm here. It's going to go to the third server, are you there? And the server is not going to answer. It's going to remove it from the rotation. And Deepak will get to your answer with regards to Terraform and things like that very soon on the next break. What's also cool is that the load balancer can terminate your SSL connections. Why is that so neat? See, SSL is an encryption technology and it's kind of rough on the CPU. So if we can actually take or offload the SSL or the encryption off of the web server, we can further scale the web server. So these load balancers are going to help in a lot of ways. They're going to help with performance, they're going to help with scalability, and they are just really, really cool. So, and they improve performance. So let's first talk about the network load balancer. The elastic load balancers in AWS, the network ones, are really fast. Millions of requests per second, really great with rapidly changing patterns, and they're stateful. So, you've got a load balancer, goes to 10 servers. Mike goes to server 1. It keeps my connection on server 1 until I'm done with it. This is, by the way, the sticky sessions occur because there's a mapping of the source and destination. So on network load balancers, it's automatic. If I go to server 1, Chris goes to server 2, Taya goes to server 3, and Vikas goes to server 4. Until our sessions are done, we're going to stay on the same servers, which is really kind of cool. Now, when our connections are done, it'll be torn down. But they're stateful, which means you're going to stay on the same thing, which is really helpful. Now, the way these typically work in a web environment is what you're going to do is you're going to put a static or public IP address on the outside for external load balancers, and on, of course, internal load balancers to your organization, you don't need a public address, and then private addresses on your systems. Now, network load balancers actually have the ability to route between containers, even though people typically think of application load balancers with that, but they definitely can do it. So let's look about the way this could actually be used. You could have a network load balancer here where you've got your systems and your users are being routed to different EC2 instances across availability zones, increasing your performance, increasing your speed, and increasing your availability. Now let's talk a little bit about application load balancers. Like I said, application load balancers are extremely intelligent. They're really looking at a lot of different things. They're looking at the path provided in the URL, elements in the HTTP or HTTPS header, things like HTTP method-based routing like push or get. They can route based upon source addresses. Lots of intelligence in an application load balancer. So if you're going to balance HTTP or HTTPS traffic, this is probably your best choice. If you're going to be dealing with lots of requests and microservices or containers, this is generally your best option. And it's perfect if you're going to load balance between multiple requests, maybe even on the same compute instance. So basically you've got a one server and you've got a couple of virtual machines in the same server. This could be a great way to do it. Also can be used to load balance between your VPC and your on-premises data center. Again, your connections are kind of stateful here. Realistically speaking, the way these load balancers work is you've got your load balancer, they listen for a certain thing, and then distribute it towards targets. That's typically the way they work. And while they're doing it, they're checking to make sure the targets are there and healthy and alive. Hope that makes sense to people. You can see they've got a listener, they're listening to requests, and then they distribute traffic in a nice, clean, elegant sort of way. So now let's talk about the classic load balancer, which again is really nothing more than a network load balancer or an application load balancer. It's an older term, and that's it. It's an older variation of a load balancer on the AWS environment. Excuse me. Excuse me. I have a lot of allergies and I'm allergic to cats, but I have a really great cat that I picked up that I just can't not play with. So I have a little bit of allergies sometimes. So apologies for the sneezing. So now let's getting back to the classic load balancer. It's just a network and application load balancer. It's a legacy platform. So it would work both in, EC2, classic, or VPC environment that we're using today. It's going to have auto scaling capabilities just like the new ones, and they can be application load balancers or elastic load balancers. Can terminate SSL connections just like any other environment, and they work kind of perfectly. So an application load balancer is very similar, or a network load balancer, classic load balancer, very similar to the new ones, just an older version, not recommended that you use them today. Okay, let's talk about the concept between an internal load balancer and an external load balancer. Internal load balancers balance things for internal applications. So let's say you had a corporate intranet. Basically you had a web app and database tier for your private applications that you don't want exposed to the internet. Very common. What do you have? If you've got more than one server, you need a load balancer. So you'll have internal load balancers, internal your organizations, all with private IP addresses without connecting to the internet. That is an internal load balancer. By comparison, if you wanted a load balancer to connect to the internet and front end your web servers for the internet for public consumption, that's an external load balancer. That can also be called internet-facing load balancers. So load balancers can be used internally, externally. The difference is where your connections are. Inside your organization or VPC, internal. Outside your organization, facing the internet, external or internet-facing load balancers. Now, when you're setting these things up, and you're configuring them, or you're architecting them, you need to kind of know the terms the way AWS describes it. And when you're dealing with third load balancers, you have the concept of both listeners and targets. So let's talk about what those are. Listeners are basically processes that wait for connection requests. So your application load balancer is going to look for your HTTP requests, and they're going to be looking through ports 1 through 65535. And of course, your network load balancer is going to look at the protocol, whether it's UDP, TCP or TCP UDP or TLS or something like that, and ports again 1 to 65,535. So that's where they're going to listen. This is where they're going to, and this is where they're going to take the traffic. Now, where they're going to route the traffic to is going to be the targets. And the targets are where it's going to distribute the traffic. So the targets can be an instance, or it can be an IP address. So we could set up either way. If the target is an IP address, it's going to have to be in either the private IP address space specified by RFC 1918, or the shared address space specified by RFC 6598. RFC 1918 specifies the 10.8, so the 10.0.0/8, the 172.16.0.0/12, 192.168.0.0.16. They're the RFC 1918 private addresses that I talked about yesterday that we've all been using. Now, later they, in RFC 6598, they specified the 100.64.0.0/10, and that's shared address space. So that if you're going to use an IP address as a target, it's going to have to be one of those. What does last two concepts we need to talk about, or a couple of concepts with regards to AWS, the concept of a target group. Instead of just going to one target, you could group your targets together. So I could create a target group that's say got 10 servers, and I could use the output of the thing to a target of the load balancer to a target group. And the next thing we'll talk about is sticky sessions. Network load balancers by default are completely stateful. They keep you on the same session the entire time. But an application load balancer works a little differently. It'll route every request to the server with the lowest load based upon the responses it gets to the health check. Now, when we're talking about this, is that the right way? Maybe, maybe not. You might want to keep the session between the user and the receiver open all the time. There's lots of good reasons why you'd want to do that. And if you want to do that, fantastic. You need to enable sticky sessions. And what's going to happen on the application load balancers, you're going to have to, it's going to create a cookie, and it's going to use a cookie to track the connection. That's where it's going to keep the user and the recipient, the user and the server together. So network load balancer does it just by the way they route traffic, TCP, UDP port, and go through. But when you're dealing with application load balancers, since they dynamically go to that server with the lowest load, if you want to keep a session on a single server, you're going to have to set up sticky sessions, which are basically going to use a cookie to track the connection, and that's the way they're going to work. Lastly, we talked about health checks, and basically they're used to check the availability of a instance. If a health check occurs and something doesn't exist, the instance gets marked as unhealthy. In case you see that on exam, if an instance does not pass a health check, it becomes unhealthy and gets removed from the rotation. Now, this is an ugly concept. I would typically only talk about this in an AWS Advanced Networking course, but we want to give you things that are necessary to help prepare you for life and help prepare you for the job in addition to just certification. So we're going to talk about the elastic load balancer sandwiches. There are times where you need much greater features and functionalities by what's available from a cloud provider. Yesterday we talked about using security implementations that are more sophisticated than WAF, like from the marketplace, like the big enterprise things. Now, if you needed greater functionality than you would get from one of the AWS load balancers, you can still do it. So, for example, F5 load balancers that we've all been using in the data center for the last 20-some years, F5 has done nothing other than DNS and load balancers that I know about for 3 decades practically. So they make incredible load balancers and DNS environments because that's all they do. So there might be times where you need the kind of features and functionality that you would get on, say, an F5 load balancer. And you can do that in the cloud. Basically what happens is you'll go to the marketplace, you'll buy a load balancer, and then you'll stick it on an EC2 instance. But the problem is now redundancy. So traditionally load balancers are somewhat redundant devices. They're designed for mission critical use. When you're putting software, and you're still going to use redundancy and redundancy protocols across your load balancers, but when you're configuring software-based things, meaning you're sticking load balancer software in an EC2 instance, you're not dealing with these kind of redundant environments like you would be in other cases. So now you're going to have single points of failure in your load balancing. So that's the concept of an elastic load balancer sandwich. So if, for example, you decided that you thought you needed to use a more sophisticated type of load balancer than you actually could get away with regards to elastic load balancers, you can create this concept of an ELB sandwich. And what would happen is you would have a load balancer, an ELB, which is highly redundant, then distribute load across your own load balancers, which would be running on virtual appliances on, say, EC2 instances, which would then go to another load balancer, which would then go to your application servers. So it's a possibility you can do this. Not necessarily suggesting that this is the way you should do it, just understanding that if you needed more features and functionality outside of what you would traditionally get, that's where you would start going into the elastic load balancer sandwiches. So I don't want to drive you guys nuts with regards to that, because that stuff can get ugly pretty quickly. So we're going to talk about security next, and security is a place where I have spent so much of my time, and I absolutely love security. Security is a big topic. We're going to talk about the AWS way. We're going to talk about the way that you would do it as a CISSP or CEH. We're going to give you some really good security content here. Cloud security is a topic on everyone's minds. There's a hack of the day. It's not because the cloud is not secure. It's because people don't understand what they're configuring, and they're just configuring it. If you don't know what it is, how it works, or why you use it, not only can you not design it, but you can't configure it. Deepak, you have a question. I see, so I'm going to spend 10 minutes answering a question. How important is it for cloud architects to learn and fly Terraform and Ansible? Completely irrelevant technology, Deepak. An architect, and specifically a cloud architect, is someone that designs the systems, meets with the clients, asks the legal, business, technical, regulatory requirements, asks the business's pain points, asks the business's strategy, and then does design. A cloud architect will therefore not code, not do any software development, not be using Terraform, not be using Ansible. They are not anything related to the cloud architect job. By comparison, the cloud engineer will build the things that the cloud architect designed. They will definitely need to know Terraform because it will help them build things. After it's built, so the cloud architect design it, the cloud engineer will build it, then it'll get turned to a SysOps team. The SysOps team maintain these systems, so the SysOps person needs to be an expert at scripting. They need to be very good at Terraform. They need to be good at things like Ansible. They need to be things that, like management software types. It's a SysOps role. So if you want to be a cloud architect, you need to train cloud architecture things, which is presentation, speaking, writing, executive presence, and design skills. You want to be a cloud engineer, these things like Terraform and Ansible become very important. You want to be a SysOps professional, then it's really important to focus on SysOps tools and scripting and automation. And of course, if you want to be a DevOps professional, which again is completely unrelated to these other careers, you need to be a software programmer that understands the software release cycle, that understands DevOps tools such as Jenkins and Spinnaker and all those other tools. So it's a matter of just basically saying the right question for the right study for the right career for the right job. If you've got more questions, I am more than happy to answer that. I'm going to open the floor for questions for approximately 5 or 10 minutes. My team has told me when I ask questions, I'm supposed to actually put a link to our training, so I'm going to do so and pop that in here along with the coupon. And then, does anybody have any more questions for me? Because I can go straight to security, but I can also answer questions. The biggest thing that I want to know is that we keep you guys engaged and we keep you guys learning. So Chris said, comment security if you're ready to get into security. And if you've got something else that you want to question, comment your question. So either comment security or comment question, and I'll go with whatever you guys desire. And I'm going to wait 30 to 45 seconds for you guys to actually let me know. There's a bit of a delay. I don't see a lot of responses, so I'm not necessarily sure what your goals are. Richard Webster, how long would it take to design a good system? What a question, Richard. I've designed systems that have taken a team of 25 people 6 months to design. And I've designed systems that I was able to do inside of 4 hours. So, depends on the kind of role. As an enterprise architect or a cloud architect, Richard, if you're dealing with the kind of environments that I deal with, basically where you're dealing with the 100 largest companies in the world where you're considering migrations to the cloud, and you're evaluating speed, performance, applications, failover, redundancy, and costs, that's a 6-month project just to evaluate the cost and build the design, and it could cost tens of millions of dollars to actually design that architecture, which is going to be led by a cloud architect, and it's going to have a lot of different people on the team. Cloud security people, cloud IAM people, all these sorts of things. But if you're dealing with a small one, the smaller things that more junior architects would do, they should be able to design systems, typically speaking, in a day or two. And they should, realistically speaking, be able to do a lot of these things on the fly in the room. Richard Wester, and what happens once it is designed and built for the position of an architect? Well, typically speaking, Richard, you're designing 4 or 5 architectures for 4 to 10 customers at the same time, so it never matters. Design one, design one, design one, design one, design one. And when you're not designing things as an architect, You're still going to be involved with the executives. You're going to be a cross between the business person and the tech people. So you're going to be translating requirements back and forth. You're going to be checking to make sure everybody's happy. The cloud architect, you're always going to be involved. There's not going to be a time where you're not involved. So lots more opportunity to design it because there's much more upside on the business side, for example, than there would be on the configuration or the management side. So looks like everybody is getting ready for cloud security. Did anybody have any more questions before I move on? Because I'm seeing cloud security and I want to keep you guys happy, moving forward, and engaged as much as possible. Prior to our next section, 1 second. Ryan, that's a great question. After you've interviewed the client, you saw the client's team while designing? Absolutely. So it's pretty common, just kick off for me or at my level, meet with the CEO, CIO, CTO, CFO, find out all their business strategy. After that, meet with their VP or directors of IT. After that, work with the engineering teams, bring in the rest of my architecture team, which is going to include some cloud engineers. They're going to have some cloud sysops people, some cloud DevOps people, and that's going to be part of my team. Then I'm going to have other cloud architects, cloud security architects, cloud IAM architects, cloud DevOps architects, cloud software architects, and I'm going to have them all be part of the team, Ryan. And they're going to all work with me until the project is completely deployed, and then we'll be on another one. So there's never a point where you get out of it. You're constantly being there. And another break, we can talk about what actually happens on, what's the word, cloud architects that actually work for customers, because that's another one. And Brandon Bowman said, last question, it's a great question. Is there a lot of project management in the cloud architect role? It depends on the size of the organization. If you are on the kind of projects that I work on, you'll typically have a team of project managers that are going to make sure the projects actually get deployed on time. Not just one, but multiple. In a very small business, like a little tiny small business, the cloud architect might do a little bit of project management along the way, but it's typically less of a cloud architect skill set to do project management and much more of a design skill set. So I hope I answered your questions there. And now we'll talk about security. So going back to security, and we're going to probably talk about this in some fair depth here. I love security and I've worked in it for a while with the CISP forever and designed high security architectures for banks and other organizations. So we're going to talk about it a lot. The things we're going to cover in our security section are going to be as follows. Who is responsible for securing what parts of the environment? We'll talk about the principle of least privilege. We'll talk about industry compliance. We're going to talk about identity and access management. Then we'll talk about multi-account strategies. We'll talk about network ACLs, security groups, and WAF. We'll talk about IDS and IPS systems. We'll talk about DDoS attacks. We'll talk about the service catalog. And we'll talk about the systems parameter store. So we're going to cover a lot about the AWS environment, probably a little less about generic security unless you guys want. If you guys want more generic security in the presentation, comment below and say, I want real heavy duty security, and we'll include it. Otherwise, I'll keep it constrained to just the AWS things. You guys can tell me in the comments section. So when it comes to AWS or any cloud provider, who's responsible for what? Now, that's where stuff can get kind of complicated. See, in the data center, you're responsible for it all. You know it. You know your lines of demarcation. You got it. You get your things done. Life is good. But when you're in the cloud, it gets blurry. Why is it blurry? Because you don't have control over a lot of things in the cloud. And because you can't control everything on the cloud, you can't secure it all. So there's this shared responsibility between you and the cloud provider. So let's look at what that actually means. AWS maintains the security of the cloud. So if it's something you don't have access to, they're maintaining it, they're responsible. You maintain the security of your VPC. So AWS maintains the cloud, you maintain your VPC. So think about it this way, the cloud security is a hybrid. They're managing their infrastructure and you're managing yours. So look at it that way. So let's talk about what that really means. What do? You do IAM roles, you patch your EC2 systems, you maintain the security of your applications, you configure your systems, and you provide physical security for the devices. What do I mean by physical security? This is really important. Imagine the security environment. Imagine the best firewalls. Imagine the best security environments. Imagine all the security tech. All your systems are completely locked down, patched, and you've got the router that connects to the cloud sitting in the middle of the room. And all somebody has to do is plug into the network, and they literally violated every last bit of your security. By the way, I've seen this in really bad places, meaning environments that needed security, that I've seen this done. Do you know what happens? Somebody walks into that thing, they're on the system, and it's done. So when I say you're responsible for the physical security of the devices that connect to the cloud, that matters. Any networking things must be locked. The data center must be severely locked. It may need a security guard. It may need an armed security guard. It may need 10 armed security guards. It may need cameras based upon what your technology systems could do. If your systems are responsible for a nuclear power plant, you need security. Likewise, if you're securing somebody's photos of their baby, you might not. So you got to figure that out. And when it comes to security, you don't invest more in security than the value of the investment. You determine what your investment is, or what the value of what you're securing is, and you start looking for different things. So that's what we start talking about when we start talking about things like shared security model. So what does this visually look like? Visually speaking, what this looks like is something called customer responsibility. So I tried to describe it before. So they take care of their computing systems, meaning their servers, their databases, their networking from the serverless platforms. They manage their data centers, which they manage their network, manage their availability zones. They manage everything. Now you basically responsible for maintaining your data, your systems, your EC2 instances, your operating systems, your firewalls, your network access list, your data, if you're going to encrypt it or not, any of your things need to be encrypted. Then your networking, basically your routing of things that you control, not the things they control that you can't see. Anything you're going to do in your servers, your applications and such. That's the shared responsibility model. They manage their stuff, and they start using your things. So that's the way these kind of things work. In traditional environment, all the stuff where it says AWS responsibility, you'd have to be doing. That's the only difference. So let's talk about the principle of least privilege. What is the principle of least privilege? In the military, they call it need to know. If you need to know, you have access to it. And if you don't need to know, you don't have access to it. Makes much more sense than principle of least privilege. That's where we're getting these complicated terms that don't mean anything. Give people access to whatever the least amount of information is they need. Why? Because people can and will hurt you. In many attacks and many hacking things that occur are purely accidental. Employees delete really critical files and didn't even realize they did it. It's just an accident. So don't give access to who doesn't need it. Why? Let's say somebody compromises my password and I'm working there. Could they use my password to attack the organization? Yes. Could they get access to my password and try and attempt what's called a privilege escalation and be able to do things greater than what I can do? Yes. So give the least privileges to people that are necessary. And if a person doesn't need them anymore, yank those privileges as fast as possible. But do it for yourself too. Don't just block everybody else and assume they're bad. Block yourself, because trust me, you can and will make mistakes. That's why you don't log into your Linux and Unix systems as root and just work as root, because you will break something. You have a root account to do certain things and you don't use it the rest of the time. Same things. Principle of least privilege. Give access to what people need to know and no more. And then when you apply it into a policy, it should look just like this. Remember, we're talking about AAA, authentication, authorization, accounting. Authentication says what are you allowed to do. Authorization says what are you allowed to access. And accounting says what you've done. So what should we talk about here? Let's say the administrator tried to access the AWS IAM systems. He was allowed on. Somebody else was not required to do it, and poof, they were not allowed on. So this is realistically what we're speaking. Role-based access control, IAM-based access control, those kind of things, that's part of where you're placing the principle of least privilege. Now, there's a lot more ways we can get things much more secure than this, but it's part of your security policy, part of your posture. Give people access to only what they need to know. Now, when you're dealing with security, you're going to often have to adhere to certain standards thing. So, for example, when you deal with payment cards, you're dealing with PCI DSS. When you're dealing with the ISO, you're dealing with things like standards like 9001 and 27001 and 20017 and 18. Pretty common standards that most of these providers will comply with that are pretty standard in the industry. FedRAMP if you want to deal with the US government, HIPAA, AWS supports these things. All your main cloud providers do, because it's just required to be able to do some of these environments. Now, when we talk about identity and access management, I hate this term. I absolutely hate it. I hate any of these new modern terms that basically make something sound like something else in order to make it sound cool. Identity and access management basically is AAA. Actually, it is AAA. 20 years ago, we used to call things what they meant. We called it authentication, authorization, accounting. It was real clear. Authentication, who are you and are you allowed on? Authorization, what are you allowed to do? Accounting, what have you done? Today we call it identity and access management. Okay, basically, same thing. Who are you? What are you allowed to do? And then can we track it after the fact? So let's kind of look at it, and then we're going to talk about some of the weird concepts that AWS use, the terms users, roles, cross-account roles, all kinds of crazy terms. But they all mean something, so we'll go through it. First and foremost is basically the authentication process. You sign into the systems, you're allowed on. Next part of IAM is letting you be authorized, or what can you do? And the last side of it is accounting, what have you done? So that's realistically the way we're talking about things in terms of identity and access management. This is what needs to be, and this is the way you should do things. Now, when we're talking about identity and access management, let's talk about users, the first thing. What is a user in the AWS content? A user is a person. So in AWS, when it comes to IAM or identity access management, you have the concepts of users and roles. A user is a person. It identifies someone that has the permissions to interact with AWS resources. It's going to be created by the principal that's got administrative resources. And you can create them either the CLI, the management console, or the software development kit, think API. IAM users are permanent until you delete them. Permanent until they're deleted. So the way it's going to look like, you got a user that logs in and he's going to basically have access to specific resources, whatever they may be. So when we're talking about AWS IAM concepts, they have the concept of a principal and a root user. A principal is going to be an IAM entity that's got permission to access resources in your cloud. So that can be the root user, it can be an IAM user, or it can be a role, which we'll talk about soon. The root user is the main user when you first create the account. The root user can do anything. They have completely unrestricted credentials. It's not recommended for daily use because this is what happens like if you were logging root with Unix, where you could basically delete your entire environment. You definitely don't want to do that, not by any stretch of the imagination. So there's no way to restrict root access. So if you're going to have a root account, you really want to protect this at all costs. Use strong passwords, enable multi-factor authentication, and don't use it for any kind of programmatic access, which we'll talk about. This matters. So root user, think of it, the king and the queen of your VPC, they can do anything. So use it when you need it. Don't use it the rest of the time because you can and will cause problems. Definitely not something you want to do because you don't want to cause problems. So now let's talk about IAM from another perspective. Let's talk about users, groups, and access control policies. So when you're dealing with users and groups and access control policies, what you're really contending with is a way to make it scale. It would be completely possible if you chose to create a personal user and assign manual policies for every user in the organization. That's fine if you've got 10 people, even 20 people. What happens when you have 100,000 employees or 200,000 employees or 400,000 employees? You're going to manually go to your console, or you're going to manually go to your Active Directory and literally create something for every user, everywhere, every time? Of course you're not. You can need something more scalable. So what happens is people create the concept of groups, and they add users to groups. So what is a group? A group is the means that basically you create a policy for a certain set of people. So let's say you've got an accounting team, a finance team, a sysadmin team, a developer team, and they all need different permissions. Create a group that basically is a collection of users for accounting. Create another group for finance. Set the permissions for these departments and then add the people that you created in your system to it. So all your network admins or architects go to one thing. All your sysops people are in another place. And that way everybody has the right rules that they need to be able to do the thing in a simple, scalable, and elegant manner. Because it would just be too hard to manually create 100,000 IAM accounts. I wouldn't want to do it, would you? So let's talk about the way these kind of things work. When you're dealing with IAM, you're basically going to create a group. You're going to create a group, provide the permissions, and then add users. So it's pretty simple. And that's the way people have done it on Active Directory and these kind of things forever, forever, and forever. So let's talk about roles and tokens. So in AWS, a user is a person, and a role almost always is a system. So then again, there's other times where they're not. And we'll talk about that when we get into cross-account roles, or anytime a token is generated or federated identity. But think of it this way: user person, role, typically speaking, except in these other use cases, is a system to access another system. Now, if you're from the Linux world, instead of an IAM role, you'd hear it called a service account. If we're dealing with the Google Cloud, you don't have an IAM role, you have a service account. In AWS, you create an IAM role, and that's so a system can access another system. And the reason you're creating these roles are so you don't have to store your credentials in a stored instance. I mean, storing passwords in instances so they can talk to each other, that's pretty ugly. Because if your server gets compromised due to your passwords, it's kind of ugly. This way, if you're using a role, what you're doing is you're basically creating tokens. You're using tokens, which are temporary passwords one time, and they expire. So even if a hacker gets control of this for a short period of time, not that big of a big deal. So that's why organizations use tokens, and that's why we're using IAM roles, which typically speaking to anybody else would be called a service account. Since you know it's called the service account, if you were to see a test question that says, how do you do the equivalent of an IAM role on Google, just know it's a service account, because you might see something like that. So roles are for systems to access other systems, and roles can also be assumed by services and applications. Basically, what's cool about it is it uses short-term credentials. And the way it's getting these short-term credentials is it's going to use the AWS token service, where you're going to want to access something, you're going to get a token, you're going to provide the token and authenticate. So realistically speaking, we're there. Tokens are temporary. The default token expires every 60 minutes, but they can be set from 15 minutes to 36 hours based upon the need for scalability versus security. The longer the expiration, the more it's going to be scalable because it'll be less work. The longer the expiration, the more damage can occur if somebody compromises your password. So you got to think about this. Everything in architecture is a trade. Security versus performance, or availability versus performance. There's always a trade. So understand that's the trade here. Now, if you're going to use to grant permission, the roles are typically used, as I mentioned, to grant permissions to EC2 instances, but they can also be used to basically access another account, like another VPC. So you can create a special type of IAM role to connect to an external organization, and that's going to be called the cross-account role. IAM roles, instead of being just systems accessing other systems, also are involved when basically you're federating to an identity provider or Active Directory or something like this. So what are IAM roles? Predominantly systems accessing other systems, but they can also be people now if they're coming from an external identity provider, like, for example, Active Directory or Facebook or something. When you get a federated identity environment, instead of being an IAM user, it's effectively going to be an IAM role, even though they're using the user functions, but they're going to be using temporary access tokens, which is how it makes it safer and secure in these environments. A cross-account role, by comparison, is an IAM user that has access to another account. Because it's another account, they call it a role. So just understand the various types of roles and security services when you're dealing with AWS. So we'll talk a little bit more about the token service. And the token service is designed to provide a trusted relationship and authentication by using one-time security credentials. So the way this works is you need a token to access something, get a temporary token that's good for 50 minutes to 36 hours based upon the expiration. When these credentials expire, they are no longer used or recognized by AWS, which means you're secure. So that's a good thing. Every time you need to access something, a new temporary credential is going to be generated. So that's going to give you some good security. Now, I briefly mentioned that we would, realistically speaking, talk about connecting one account to another account. Now, the way you do that is you create something called a cross-account role. And this is because you're basically creating an IAM user in an account that you don't own. So basically speaking, that's called a cross-account role. Now, when you're dealing with IAM roles across accounts, and you're allowing people access to your system, but they're not from your internal organization, think security, think more security, and think more security. Why? That's what it's going to take to lock down your systems, a ton of security. And if you're letting somebody that's not part of your organization in, now you may prevent business opportunities, but now you've basically invited people into your house. This is where the security problems, this is where the security challenges occur. So how do you deal with this? First and foremost, you be very, very granular in what you allow access to. The principle of least privilege, which always matters, never matters more than when you're inviting external users inside of your system. So definitely kind of focus on this, kind of think about this. It's really important. When you're allowing access to your systems, make sure that you really lock down what people can do. And that way, so if you're going to set up a cross account, it's really about knowing the external ID that you're going to associate with the role. It's going to have a secret identifier that you will know and that's known by you and the third party. And you're going to have to specify the ID and when you define a trust policy. So this, there's some work to set this up. It's not that complicated, but it's really important. The permissions are needed by the third party, obviously, to verify what you can do. So what does a cross account role look like visually speaking? It looks like this. You've got multiple companies that are allowing you access to their systems by creating a cross account role, which is giving you temporary access that's using a token-based system based across accounts. Now, IAM is not a fun thing to talk about. Apologies, but it's definitely something you need to know for the Certified Solution Architect Professional exam. And IAM, while being a small part of security, is definitely a part of security that's pretty important, so we have to talk about it. Now, I had mentioned previously cross-account roles and tokens, so let's just walk through it one more time because it's kind of complicated and hard to understand. I had to read this a couple times to look at the way AWS did it because it's slightly different than others. This concept of the cross-account, you create a role, and then the external user connects to the token, AWS token service, SDS, receives a temporary token, then the user provides the temporary token on an automatic sort of basis, and they get access to the VPC. And guess what? It's so similar for your service roles for EC2, like a service account or when an EC2 instance attaches to another one. What also happens is, the application is going to make a secure API call, or it's going to make a call. It's going to get a token. It's going to provide the token. And the kind of service roles that you could be creating would be so that maybe EC2 can post to an SQS queue, an EC2 system can access an S3 bucket, an EC2 system can access a relational database. These are the kinds of environments for which you're going to definitely need to be creating a, what's the word I'm looking for, a service account or an advice, or either a service account or a cross-account role. And you can see the way this looks visually speaking. You take your EC2 instance, you get a role, and then you access DynamoDB. I'm sorry, that was not fun. When we start kind of talking about IAM users, IAM access, IAM roles, principles of least privilege, this is where things get a little more ugly. So, but they're all really important. So what I want to do is I want to stop here and then pause for a few seconds and then ask you guys, do you have any questions on any of this? Because this stuff gets kind of ugly, and I want to make sure that you all are good before we move forward. Are there any questions here? I'm going to wait approximately 30 to 45 seconds. While I do that, and okay, I don't see any more questions. I thought I would use that as a chance to check in questions. That is completely fine. If you have questions, we'll answer them. Deja, I don't even know where to begin with what you're asking there. If you're dealing with what goes on between resources, that's the if that's the question you're actually asking for. If you're asking for how one system accesses another system, it's with an IAM role, also called the service account. But if you have a deeper question and you'd like some clarification, I'm happy to answer that, Tejo. I will do what my team tells me. I'm going to post a link to our Cloud Architect career training. And Derek, great question. Why would a company trust MFA sign in from Google or Facebook? So they're only partially using it. So they're not going to completely trust all the information that's coming in from them. They're going to be looking for partial sets of information. Typically speaking, at some point along the line, it's going to pull your username, your password, and these other things from your trusted identity providers. But then they're going to set up a policy on their end, Derek, to determine how far they want to trust it and what they want to allow you to do. So if it's like just log in with Google, what are they truly logging into and what are they getting access to? But if it's actually coming into deep into your systems, you're going to have to do a lot of work, Derek. And it's a really great question because you're not going to allow everything from Facebook to necessarily allow you access to your private systems, just minuscule things. Like, for example, log into Reddit through Facebook. That's a federated identity environment. You might use that as a login, but before you build your account on Reddit, you're going to have to add all these things so that they can verify it's you and your permission. So it's a partial thing to verify these kind of integrity things. Great question, Derek, when you're doing it, because otherwise you can't necessarily do it. Sir Khan, now this is the next thing that we're going to talk about, and this is true. We typically, it would integrate IAM in the cloud with Microsoft Active Directory. Active Directory is typically what organizations use for their IAM, so typically we'll talk about that. That again is federated identity, but that's a very common use case, and that's typically where you have the trusted thing. Next question, by K1 Erzan. You bought a domain with one account but want to move it to another account. Is that possible? Yes, you can always move one domain to another account unless it's got some of those things that says do not transfer. Typically speaking, you have to wait 60 days, K1 Erzan, after you registered it to move it to another account. But yes, 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 it's completely possible, and do it all the time. Prior to getting to the next section, if you guys are enjoying it, if you can leave a like or a comment, share with other people that you think would be helped by this as well. And we'll get back to some training right now. So as we go through these things, if there's areas that are complex, and when we start talking about IAM, it gets incredibly complex. And it gets complex, so if you guys need me to stop and go over some things, I am more than happy to do so. I want you guys to have an incredible experience so you guys can build some really great cloud architecture careers. Okay, Tejo's question. Custom roles, is it possible to create based on standard? Yes, Tejo, you will talk about how you can do it, but you can create any kind of custom role you want. If you want to write it in JSON, you could use a managed policy that AWS has, which we'll talk about. And you can tune a managed policy, so we'll talk about lots of things that you can do with regards to creating IAM policies very shortly. Great question there, Tejo. So now let's go back to talking about identity management. Now we're going to get into the concept of identity federations. So getting right into that question that Sarkan asked, which is the perfect question. How do you scale this? First and foremost, chances are you're not going to be manually adding users for a 200,000 person global enterprise, or at least I wouldn't be. But I might want to federate or share data with an identity provider. Now there's lots of identity providers, internal identity providers and external identity providers. I would happily trust my internal identity provider that I set up. I wouldn't be trusting an external identity provider for much of anything, other than the fact that a user is the username, password, email address, maybe their phone number, that kind of thing. Not whether I can trust them or not. The most common identity federation that you're going to set up in your environment is going to be federating with Active Directory. Active Directory is an identity store which almost every big business throughout the world uses, and it's going to be a key component of organizational identity and access management. Basically, the way this works, you're going to have an identity who's going to be a user. You're going to have an identity store, which is where the stuff is put, where the identities are placed, and then you're going to have an identity broker. An identity broker, realistically speaking, is going to be an application that performs the checks with the identity store, basically where your temporary credentials and access to resources come from. So here's what it's going to look like. Your user is going to log into the identity broker, Microsoft AD, for example. And the identity broker, typically what it does is it authenticates against like an LDAP-based identity store. And then as soon as this happens, what happens, the identity provider generates a SAML-based assertion with all the required information and then submits the assertion to the identity broker. At that point, the identity broker is going to basically do what's called like an assume role with SAML, Security Assertion Markup Language, which is a language to connect to these providers. And then it'll hit the token service API, and then what it's going to do is post the SAML assertion and assume a role. And then after assuming the response was successful, the user is going to get a temporary token, and they're going to use that temporary token to access it. So basically, let's say this again: user logs into the identity provoker, that gets authenticated against the LDAP or the type identity score. It's going to generate a SAML assertion, which basically is going to submit it to the security broker, and then you're going to assume a role, assuming everything goes on, and then from there you're going to get a token, and you're going to provide that token, you're going to get access to the systems. That's the way these environments work. Identity federations can enhance your IAM scalability dramatically, because it's one thing to do it in a federated environment, and it's another thing to try and do it manually, user by user. That's going to be a real challenge for everybody. So basically, you establish a trust relationship between AWS and the identity provider. Same kind of things that used to happen in Microsoft Active Directory trust between FireHost and things. They've changed over the years, but it was always based upon trust preventions. And typically, when you're making these connections, you're going to do it with Open Connect ID, OIDC, or you're going to use Security Assertion Markup Language 2.0. For the most part, that's what you're going to use. When you're dealing with external identity providers, think Google, Amazon, Facebook, Apple, Twitter, LinkedIn. And of course, you can use identity federations to connect your AWS VPC to other management applications like Active Directory. This is always done via SAML 2.0. So typically speaking, that's the way I would be federating in most cases to Active Directory for my organization, to use in my organization. Done lots of this in my career. So when you're dealing with AWS, your identity functions are connected to the identity provider. When a user is going to attempt authentication, a request will be sent to the identity provider. And what's going to happen is the user is going to get an IAM authentication and get their privileges based upon their job, cost center, other factors. And when they have their privileges, then they're going to know what they're able to do. So granular control of users, simplicity, kind of elegance. Now, and this topic might be heavily tested on your Certified Solution Architect Professional exam, is the concept of single sign-on. Single sign-on is an authentication method that basically enables your users to securely authenticate to the systems and multiple websites with just a single sign-on. So sign on once, get access to everything you need. Single sign-on is a service that's going to allow the user to sign in one place and not have to keep signing in. It's typically used in a federated environment, and it typically integrates with Microsoft AD, Azure AD, Salesforce, and others. It enables your users to authenticate once and do it again and not have to do it for everything they do. So they're signed on, they're authenticated against the identity provider, their group is determined, the privileges are assigned, and then they have access to your systems. That's it, access to your systems. So look at it this way. You go to your single sign-on, it hits your Microsoft AD, it gives you permissions, and you access your systems. Simple, elegant, beautiful, really terrific as far as it goes. Now let's talk about other ways on the AWS cloud you can do identity federation. You could use something called Cognito. Cognito, or Amazon Cognito, is a service that provides authentication, authorization, user management of web and mobile apps. So, in other words, it's a means to connect to identity providers. It basically enables you to synchronize your identity management across multiple devices. Phone, computer, get in, simplified access to the systems in a secure environment. Enables you to sign in directly with your username and password, or use some third-party service like Facebook or Google if you're willing to allow that to occur based upon your security policies. How it works: user authenticates against Cognito, they get a token, the token is then used to access AWS resources. Nice, simple, elegant. Some of these services in the cloud are really beautiful. Like I said, sometimes I'll tell you when you need more, like when it comes to a better firewall, and sometimes I'll tell you when something like this is perfect. This is beautiful. Authenticate, get your token, use your token, get access to the services. Simple, elegant, secure. When you have these opportunities in life, doesn't happen that often in architecture, you take them. Because you're not usually that lucky. So let's talk about some more federation with Cognito and how it works, in case you come up with some test questions. Cognito uses the concept of a pool, a user pool, and an identity pool. And the user pool is a secure directory of the people that can use it in one place. So what happens is you successfully authenticate and you get a temporary token, which of course is going to be a JSON token because all this IAM stuff is in JSON in the first place. So we'll talk a little bit more about federations. Cognito pools basically give you temporary access. Now that's the key to remember with all this stuff. It's temporary. When you're federating, you're getting temporary, so you can't be accessed forever. So temporary access to certain things. So therefore, if anybody obtains the token, they can't do that much damage to you. Cognito can work with authenticated and non-authenticated identities. So can work with guest accounts as well, people who haven't received the token. How does this Cognito work step by step? I'm going to tell you. The user logs into the identity provider. The identity provider returns a session key. Using the session key, the application will call within like an API get ID call to basically get the identifier for the user. And then what's going to happen is Cognito is then going to validate the session key and give it from the login provider. If the session key is valid, which hopefully it is, you're going to get ID API is going to return a unique identifier for the user. Now, that's great. The user is going to send their unique identity to Cognito, which is going to be validated against the session key of the identity provider. And poof, they're going to get a token, and then they're going to have access to the resources. Sign into the provider, get authenticated. You're going to use the session key that you got with part of the authentication to call your Cognito get ID. Cognito is going to validate the session key. After it validates the session key, you're going to get an API returned to you. Then the user is going to send the unique identity to Cognito. Cognito will send you a session key, which will give you a token, and then you'll be accessing the systems, and that's it. So that's the way these kind of things work. Now, if you wanted something else that was scalable, and you didn't want to manage your own Active Directory service, well, you don't have to. Amazon has an AWS Directory Service, which basically speaking is just hosted, dedicated tenant, Windows Active Directory services. So that's it. You could do this on an EC2 instance and set it up. Or you could use the AWS Managed Directory Service, which is just hosted Windows servers. When you use their service, they're theoretically high availability servers spread across 2 availability zones by default. And these AD services are really great for organizations that use a lot of Windows-dependent workloads. Exchange, Microsoft SQL Server for people that are actually using that. Some organizations have a lot of Windows workloads. If they do, they typically use the Active Directory service. Even organizations that don't have a lot of Windows workloads often use the Active Directory service because it's just a simple, elegant, highly scalable, enterprise-grade means to authenticate your users. So when it comes to authenticating your users, what are your options? Well, you got a couple options for authentication with regards to AWS. You could use a username and password. We've all done that before. Now, that's got its problems. You could use an access key, which is basically a 20-character key ID and a 40-character secret. So it's going to be a lot more secure than your password. And the access key is typically used to connect to AWS via an API. So think software development kit. And then if you need something better, you can actually use the access key and a session token. And what's going on here is when you request IAM authentication, you get a token. And then you basically take the token and the access key. So you're basically taking a temporary thing plus the 60-character access key. And now you've got some real things that are giving you some access control, authentication control. Authentication control. Now, when it comes to authorization, remember, we're going to use the least privileges that are necessary. And the authorization is going to come from a set of policies, which we further defined in the users, groups, or roles. And we're going to talk about writing a policy. And the policy is going to be written in JSON, JavaScript object notation, which is the way all these IAM policies are actually going to be written. The default policy is deny access. So if you want access to services, you're going to have to configure them. Now, I am not an IAM policy writer by any stretch of the imagination, but basically the things that you need to put here are basically the effect. Are you allowing or denying a service? Under service, what is the service for which you're going to access? You need to define that. Then you basically need to identify things by the resource. And what I mean by resource, it's going to be the full Amazon resource name. And it's going to look something like one of these ARN:IAWS.IAM, and it's going to have your information there. It's going to have an action. What does happen? What do the users do the permission have? And then it's going to be a conditional. What do you want to happen? So the thing, allow or deny access to what is the service, and the service you're going to identify the resource, and what can happen, read, write, full control. That's what's going to be inside of your policy. So what's it going to look like? It's going to look like this. User logs in, they request access, and they get authorized for something. And they get authorized for something, they're allowed to use it. So now when it comes to creating a policy, what's the best way to do it? And this gets into Tejo's question that's before. We're going to give you a couple ways to do it, but you can basically use an AWS policy, where you can make a customer managed policy. AWS has some really good managed policies, so we're going to talk about how to use that. But when you're creating a policy, you can also use wildcards like regular expressions like stars and things like that. And we'll show you a little bit more about what that means. Now let's get into AWS managed policies for a short period of time. Basically, AWS has created standalone policies for most common business use cases, which is really pretty terrific. So what's going on? The policy is going to provide permissions for certain functions inside of it, and they're going to be optimized for common use cases. So this is really great. You can pull a policy from the shelf. They've got something for root accounts or the equivalent. They've got something for administrators. They've got something for power users. They've got roles for lots of things, and they're pretty much what you need, and you can tune these roles. So you don't have to be like an IAM expert to try and create your IAM policies. Now, when you're dealing with big cloud architecture environments, and you're a cloud architect and you're going to create an IAM solution for a big bank, they're probably going to have some IAM architects with you, and this is going to be their specialty, and this is going to be all they do. Because this kind of stuff is going to get beyond the depth of the average cloud architect. But you will have cloud IAM architects doing these kinds of things. But AWS managed policies, standalone policies for the majority of use cases you actually have. So how do you create one of these things, or how do you use them? Basically, you sign into the IAM console with administrator privileges, and in the navigation page, just choose your policies, and you're going to see a list of managed policies. Simple to use, updated by AWS, and it helps you avoid configuration errors. Meaning, pre-made, if you're not an expert on JSON, use this. Now, you can also create your own policies. So, you could take one of the policies that actually exist before, and we could talk about how to do that, but you could create your own policies. Now, if you create your own policies, they're going to be private to you, meaning nobody else will be able to see it outside your organization. They're going to be custom made for your needs, and you attach these within the entities of your account. So, how would you do this? Well, you could do it one of three ways. One is you could basically copy an AWS managed policy and tune it. Very simple, elegant way to do it. Next option is you can use the policy generator. I'm going to show you that in a minute. It's basically a web page. It gives you basically close to a questionnaire, and you assign permissions to specific resources, and a policy document is written in which you can edit, and basically everything's done for you by answering some questions. The third option, and this is only good if you're a JSON programmer, so only good if you're a JSON programmer, and with that, basically you can create your own policy. So let's look at what these things would look like. Using the policy generator, where you're at over here, you can basically see the policy. As you can see, you answer some questions and you get your answer. No big deal. You could copy a sample policy and tune one of these things. No big deal. If you are a software developer or good with scripting or good with JSON, that's totally fine. If you're a sysops person that does this kind of stuff all day long, great. If you're a cloud engineer that's used to scripting, great. If you're an architect and you don't have software development skills, go find somebody to make sure that they do this when they build the systems. You can create the concepts and the architecture and let somebody else build this if you're not. Otherwise, use the managed policy. So let's talk about applying these policies. So you create a policy, and what do you do with it? So you create the policy, and then you have to apply it somewhere. So typically speaking, you could apply it to the user, but that would be manual and that would be ugly. You'd have to create the policy for every single user and manually apply it. We talked about not wanting to do that earlier. We could basically create a managed policy, which is basically something which we pulled from them, for example, use one of the AWS managed policies and say, add it to all the users of finance or all the users of accounting. And of course, we can create a group policy for a group, and then this is how we scale. So any of these policies before can be defined in users and groups. Group policies scale because basically you can take everybody in a certain job role, create a policy, and then add them to the unit. So that's realistic what you're going to do. And what does this kind of stuff kind of look like? I'll show you. So you create a group admins, developers, test, and then you apply the users to their groups and they inherit the permissions of the groups. This is the way everybody does it. This is the way Microsoft Active Directory does it. This is the way I highly recommend you do it. I think you'll get a headache, and I mean a huge, huge, huge headache if you were to try and create something for 100,000 users. I wouldn't want to do it. We've got to scale. So this is how we scale. Now, we're talking about IAM, and I'm going to take frequent breaks in this section because we're not talking about the cool security stuff. We're not talking about firewalls and IDSs and really crushing and killing attacks. We're talking about IAM, which is the least fun thing that I know to talk about. So I appreciate your attention. I appreciate your sticking with me all this time. I appreciate your fight and your effort. You guys are doing really great. Thank you for that. Thank you again. So how else can we further secure things? Well, we can also use multi-factor authentication. So now we're using passwords, we're using keys, we're using tokens, but also add some multi-factor authentication. Why? If somebody compromises your password, you got a problem. If somebody gets your token, it's less of a problem. Let's add more. Let's add multi-factor authentication. Multi-factor authentication comes from the concept of something you have and something you know. So think of your ATM card. We used to call them MAC cards many years ago. Something you have and something you know. What do you have? The card. What do you know? Know the PIN code. So that's what we're really talking about with multi-factor authentication. It's going to further enhance your security by requiring you to have things and know things. So typically the way multi-factor authentication works, and it can be lots of different ways. You typically set up an authentication app, or you have a RSA secure ID key, and it creates a one-time password that changes every couple of seconds. So you're going to log in with your username and password. You're going to get a challenge, and that's going to be for that one-time password. You're going to provide it, and then you're going to be allowed onto the system. So what's that look like, architecturally speaking? User signs in. User basically gets a challenge, and then the user provides access to the system. That is it. Everybody's up, everybody's running, and things are working fantastic. That's typically the way these things kind of work. So let's do the following. Let's go back, open this up to questions. I've gotten into ugly IAM things, but they're important, they're essential to know, so I wanted to give you everything you needed to know. Does anybody have any concepts on this? I'm not an IAM architect, but I will do what I can to answer your questions because IAM is still a very important concept in the cloud. And there's definitely a latency challenge when we do these kind of things, so I have no control over that, but my apologies. Any questions before we move on? Give you guys a couple more seconds to ask any questions in here. I've covered a lot of IAM things very fast. I don't know what CCA is. One thing I advise you all in your careers. Thank you. Thank you so much. Really appreciate everything you're saying there. Appreciate your support. And we are having fun, even though we're talking about IAM, which is our least favorite topic. So because we're speaking about our least favorite topic, we know it might be yours as well, so we want to do everything we can. Do you guys have any more questions before I continue? Otherwise, so Ken. Would there be any scenarios where integrating on-prem AD? Well, that is it. So one of these questions is quite simple. Who in the organization would be the IAM administrator? Okay, how would you design a cloud-based cryptographic artifact management solution in the banking industry? UI, we can talk about that, but that's a conversation that would take about 8 to 14 hours. And it would realistically speak taking about 2 weeks of deep dive questions to a bank long before we would design it. So when it comes to architecture, it's like being a doctor. You basically ask questions, ask questions, ask questions. obtain all the requirements, then do a long evaluation, and then after that, that is how and when we're actually able to do something designing. So we could talk about those kinds of things. I am not an artifact management solution person at all. That's a little bit out of the cloud architecture world, but I'm pretty familiar with cryptography and the way these kinds of things work, and happy to do something like that, but that would have to be a very, 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 very long discussion and not something that could fit in the time that would go into a certified solution architect professional course. That's why I was saying when it comes to being a cloud architect, certification is 10%. The remaining 90% is communications, knowledge of the network, the data center, the industry, all of these kind of things. Joe White, you have a certified solutions architect. After completing my career development, do you have to go off and get the certification professional before putting forward? So Joe White, inside of my 16-week program, you would learn the following. You would first learn what the cloud is. Secondly, you would learn how the cloud works. Third, you would learn how to you would learn how to design everything. You would become an expert on the network and the data center. You would become an expert in systems design, and you would be an expert in systems communication. We would still need to make sure if you have a lot of experience, you would not need any certifications whatsoever. Assuming you don't have any experience on your history, we would still need to get the Certified Solution Architect Professional certification. The Certified Solution Architect Professional certification you would do inside of my program. It is very simple when you understand how the tech works. It is extremely complicated when you don't understand how it doesn't. One of my people very recently joined my program. He's there for 3 weeks. And he's already passed the Certified Solution Architect Professional, and he had 0 certifications before he met me. So very simple to do these certifications when you understand what all these things are. If you're just watching a Udemy course and you're memorizing a bunch of questions and answers via practice tests, it not only will not mean anything, will not be useful in the end, but it's going to be a very challenging exam. So Joe, is it necessary to always have the Certified Solutions Architect Professional? Lots of times it is, and lots of times it isn't. I can't answer that without knowing, and I'm happy to discuss it with you further. But I will say this, that it's definitely necessary, but I can't recommend a certification or lack of a certification until I know what's necessary. But if it's your first job, typically we need the Certified Solution Architect Professional, as well as something specialty in your career. And if you've got any questions, you can ask me. I've dropped my phone number. This is the last week my team was allowing me to answer those, to do this. They've basically taken my phone away from me and got me a new phone. So this will be my business phone number as far as next week instead of just my personal number. So I've been doing this because I love really speaking and selling to my customers, but my phone's being taken away from me by some of the other operations people in my team. So if you guys have any questions, call me and I will definitely answer that. Joe, I hope I answered you. How would you design it? Well, that's way outside of the scope of here, but we can definitely discuss it. Who in the organization would be an IAM administrator? Wow, that's a great question. Typically speaking, you're going to find your IAM people in one of 2 places. You may have a chief information security officer who may have the security team, and they may have a subset of IAM people there. They could be reporting into the CIO through the traditional IT teams. They can also be working your IAM people often on the system side, like the PC side. Why? Because it's Active Directory, and Active Directory is Windows, so you often have your systems admin, specifically your Windows people doing it. So it could be a combination of different things. Typically not a cloud architect role by any stretch of the imagination. Cloud architects are involved in the design of these systems, but it's definitely not a cloud architect role. There's typically a cloud IAM architect and typically a cloud IAM engineering roles. Recruiters ask me for these people every single day for my students. It's just that I don't typically train cloud IAM roles. I train cloud architects. They have a lot more career potential, and that's the world that I love. I hope I've answered all your questions. If there's any more questions, let me know in the next 30 seconds. Otherwise, what I'm going to do is I'm going to go back to the training, and I'm just trying to take some breaks periodically because I know how hard some of these IAM things are to really look at for lots of periods of time. Any more questions for me? Okay, if not, thankfully we're getting out of the IAM, or we're getting involved with some more things that can become a lot more cool. So before we get into the fun stuff, we've got one more thing to talk about, which is basically called multi-account strategies. And what is a multi-account strategy? Let's say, for example, you have everybody in a single environment, and you've got your development, your production, your users, all these kind of things in a short period of time, and something goes wrong. it's possible that basically one part of your thing can take down your entire system. So that's bad. So in the military, they call it blast radius. Maybe if a bomb were to go off, how many things would affect? And guess what? In the cloud architecture world, they also call it blast radius. How do you minimize the blast radius? What would happen if one thing breaks, and how would it affect every other system along the way? So when you're dealing with these kind of situations, you'd create a multi-account strategy. So what does a multi-account strategy do? It kind of breaks your environment into multiple small accounts. Now, let's talk about the good and the bad of this and why you would do it. Now, if I wanted to really secure my systems, initially, I would have a VPC, for example, for dev test, a VPC for production, a VPC for lots of different users, and they'd all be separate. That'd be great. Here's the problem. If I have 4 entities, each entity is going to be separate, which means when you have things separate, the chances of getting discounted bills is going to be lower. See, what happens anytime you're negotiating with a technology customer, the more you can buy, the better your discount. Typically speaking, a global enterprise can get 40 or 50% off. So by having a lot of volume. But if they have more small accounts versus one big account, maybe they only get 25% off for each account, so it's a lot less. So you want to combine the billing under a single bill for economies of scale and billing discounts, but you want to have the separation to reduce blast radius. AWS lets you do that, and it lets you do that with organizational units. So an organizational unit basically enables you to have one single billing organization and yet be able to separate your users to provide security. So this is pretty cool. So let's look at what this actually looks like for a second. You've got an organization, you're breaking it down into organizational units. How cool, how wonderful, what a great way to further enhance your security and segregation of your users. So what you do is you create something called a service control policy. And it's basically like an IAM policy, but it's a policy to restrict actions across your organizational units. So you can define the service control policy at the master organization, and that's going to restrict the different accounts that inside there, your different accounts in your various services. So this is the way we're going to do these things, and this is the way your multi-account strategies will work. My team has reminded me that I forgot to ask if you're enjoying the content, if you're liking things, if you can leave a like or a comment or subscribe to our channel. It helps our organization grow, and that enables us to provide more free training options. A lot of people have asked us to provide from free network training. So if you guys want from free networking training, we're going to do some live free networking training, type network training in the box below. And now we start getting the cool stuff. Now we start getting into the security parts that are actually fun and enjoyable that I'm happy to talk about. First, we're going to start talking about firewalls. And thank you, Chris, Showbiz. We love doing these sessions, and we appreciate your feedback. So let's start talking about how do you design secure systems. Okay, well, actually, let me ask Tammy's question first. How difficult is it to pivot into a career when you have had the experience? I might gather knowledge, but you might say a break the hiring manager is so unlikely. So that's why I created the program, the Cloud Architect Career Development System for that. I used to practice internal medicine as a nurse practitioner, and my first job was a senior engineer, and I've been helping people transition careers now for well over 20 years. If you know what to study, know exactly what to study, exactly what to learn, and you pull off everything else, it is very easy to transition careers. But if you wanted to be a cloud architect and somebody's sending you down the DevOps and the SysOps and the scripting path, you could spend 10 years and still not know what you need to do to be a cloud architect. So very, very, very simple, Timothy. If you've got a good guide that builds you the perfect map, you can go from any career, almost any career, to moving into tech or a cloud architect career in 6 months, 9 months, based upon how much experience you have. I've done it as little as 8 weeks, and I've done it as most about 9 months. It can definitely be done, but it takes a lot of hard work. But we have a system that helps you get there. And before I go on to the new concept, which is security piece, which is really where I like to go, I'll leave a link to the program and a coupon code because you asked a question and you may not have been here earlier. So I'll provide that information. And then after that information, let's go back to keeping the network secure. So let's talk about this. So the way you secure your environment, now this is where we're going to get into real heavy duty security, not just the cloud stuff. We're going to talk about the way to do it the right way. At the edge of your network, you stick a firewall. The firewall, imagine you have a castle and it's got this big giant wall that keeps bad guys out. That's your firewall. Now in a high security environment, which means it's not available in the cloud, so you're going to have to get it from the marketplace and put it on the cloud. You have what's called an intrusion detection system. So basically speaking, in the firewall, and you go to the castle, they've got this big wall around it that keeps the bad guys or the unwanted people out. Behind it, they have this thing called the moat. And it's this thing filled with water. You basically fall 100 feet into the water. And when you get there, there's sharks and alligators and other scary things to eat you. And then if you manage to get out of that, there's a bunch of knights with swords and things like that. That's the intrusion detection, intrusion prevention system that you have. Firewall keeps bad guys out. Intrusion detection system says, hey, if you broke in, we got you. We're going to crush you. We're going to stop the attack. Then organizations have some DDoS protection, typically in the form of Cloudflare or some other DNS provider that basically provides DDoS protection. Then they protect their subnets, most specifically staking with access lists on routers, and the cloud will be network access list. Then they protect the host with something called the security group. Then they encrypt their data in case to make sure things are not done, and they use strong IAM policies, and there's so many more things that go into it. But that framework that I just gave you is your traditional framework that's done by every CEH and CISSP for locking down your systems. That is your typical critical security, the way that things would be designed for big banks and things like that. So we'll talk about what they can do. We'll talk about the AWS services, and we're going to talk about other services that also could work. So with the edge or the perimeter of your network where you're going to be connecting to, say, the internet, you got to protect it because people on the internet will hack you. If I check my firewall, people try and hack me 10 times a day. My firewall stops, and my IDS systems block stuff too. But this happens. Everything on the internet will be hacked. So you protect the edge of your network with a firewall. So the firewall's job is to keep bad guys out, bad people out, and bad hacks out. So basically speaking, that's what the firewall does. And basically you can basically filter traffic out of your system. And the way it works is the firewall is going to be a stateful device. What do I mean by stateful? Stateful devices work as following. Let's say my hand's the firewall. I'm behind the firewall. I go out to the internet. I go through the firewall to cisco.com. The firewall said Mike Gibbs went to cisco.com through me. So when the traffic from cisco.com comes back to Mike Gibbs through the firewall lets it in. The reason the firewall lets it in is the firewall says it's Mike Gibbs traffic, and I saw Mike Gibbs went to cisco.com. Therefore, Cisco traffic destined to Mike Gibbs is allowed back. Now let's say Chris Johnson wants to come in, but he's not behind the firewall, and he tries to come in the firewall. He's blocked. Why is he blocked? He's not from inside, and the firewall blocks all traffic by default unless it was originated on the inside. There's no state of Chris's connection, therefore he won't be allowed in. Now, if it comes to my house and he goes behind my firewall and then he goes to any website he wants, he's going to be allowed back in because this firewall is going to know that it was Chris that actually accessed my firewall, and he's allowed in. So that's what a firewall does. There are lots of kinds of firewalls out there. Cisco makes them, Juniper makes them, Palo Alto Networks makes them, Fortinet makes them, Checkpoint makes them. That probably compromises 90% of all enterprise firewalls in the entire world. And on the cloud, you can use them. You go to the marketplace, and if you have a really high security environment, you're going to the marketplace, you're going to get a marketplace solution, you're going to get a Palo Alto or a Fortinet or a Cisco firewall, and it's going to work great, and you're going to have lots of enterprise security. Or AWS has their own managed service for firewalls, and it's called WAF, or Web Application Firewall. And WAF is a firewall that basically monitors HTTP requests looking for exploits. It can control your CloudFront distribution, an API gateway, a REST API, or even a load balancer. And it's going to block connections at edge locations before things can even get on your network, which is cool, just like a firewall. WAF can control the content that you specify, so it does a relatively good job of keeping things out. It does a good job for most organizations and their security by providing firewall access, and it's simple to use and it's relatively low cost. It's a good service. Would a bank be using this? Probably not. They're going to go to the marketplace and get something extra secure. Would this work for 80% of the organizations? Yes. Would this not work for the top 20% that need other things? Probably not. When you're in the cloud, you're the architect, you design what works best for your customers based upon their needs and their requirements and what they're securing. WAF, like any other firewall, lets you have granular control over your resources. And basically speaking, it creates a set of web APCLs or rules that basically allows in traffic based upon what you need. Now you can create a rule permitting traffic, you can create a rule denying traffic. Think of it this way, a firewall is basically an access list that's stateful. So it knows what's going through it. You create a rule statement that basically says allow or deny based upon a criteria, and rules are basically just a set of groups, and you can use them in other places as well, and it can provide metrics to CloudWatch. So think of WAF as a firewall. You create a set of rules that determines what's allowed in, what's allowed out. If you're running a web server and you need to allow port 80 and port 443 in, you do so. If you don't, you keep it blocked. You only open the minimum number of ports that are necessary to do the job. That's it, the minimum number. So it's the absolute minimum number of what we're using. Let me just take control of this. We recommend review and prep. For certification exams, that's our main recommendation. We recommend review and prep because their CEO, Hemant Sharma, is an extremely good guy. I trust him. I know the quality of his test. I spoke with him. We do not have a financial relationship by any stretch of the imagination whatsoever, but we recommend review and prep for this. But again, we have no affiliation with him. I just have seen people be highly successful. Students have told me Pass for Sure is exceptionally good. At Go Cloud Architects, we exclusively recommend review and prep. The reason we recommend review and prep is I trust their CEO and I know their quality. I have heard good things about Pass for Sure, but I don't know them, so I don't like to talk about them. Students have told me many good things about them and they've had great success. I recommend review and prep because I know their CEO. He's a really good guy and I've seen the quality of their exams. So how do you set WAF up? You enable WAF on the application of the device. You create a policy that filters traffic across the device. So you enable it, you set your policy, and then WAF is going to determine is the traffic allowed in, is the traffic not allowed out? And based upon that, what it'll do is it'll create a set of rules to help mitigate attacks. So it's somewhat of an adaptive firewall, not as much as like a Palo Alto system or a Cisco system, but it's somewhat adaptive. Basically, you create a set of rules and it knows what to allow in or what to allow out. So let's talk about restricting network access with firewalls, what it would actually look like in the AWS context, and then later if you guys desire, we can actually design an overall security posture one by one for an organization, and I will map it out with you one by one if you guys desire. If you want us to build the security architecture for a global enterprise organization before the end of the day, type build security architecture and we'll visually do it in PowerPoint together. So while we're doing this, let's talk about what it looks like architecturally speaking from an AWS perspective. You place your WAF and it can be placed in your CloudFront distribution, your load balancer, your gateway. You set a policy and it's going to determine who's allowed what kind of access to your systems. Now, let's look at what this is going to look like where you're going to add your DDoS and your web application firewalls. If you decide to do it the AWS way, we're in an AWS training class, so we're going to talk about that. We typically use Shield, which is basically like a Cloudflare as it pertains to DDoS protection in the AWS environment. We'll talk about that in a minute. And then we'll use WAF as a firewall. So the way the policy would work is you basically have your Shield, which is protecting you from DDoS initially. And then you have WAF, which is going to be your firewall. Then you're going to protect your subnets so if anything gets through with a network ACL. Then you're going to protect your servers with a security group. Then on your servers, you're going to use malware protection. So let's define a DDoS attack because that's next what's going to happen, and then we're going to talk about how to present them. And like I said, if you guys want us to design in PowerPoint, we'll map the edge of the network, how you secure an environment. I'm happy to do that. We can do it completely from an architecture perspective. Just let me know in the comment section. So what is a DDoS attack? Because that's the next thing we need to talk about. A DDoS attack, and then we'll talk about how to prevent it. A DDoS attack is basically when you've got a hacker and the hacker compromises a server. And then the hacker uses that server to compromise a tremendous number of servers and then send a tremendous number of requests to you to basically take down the capacity of your server. So, me, the hacker, I take control of 100 servers on the internet and then I launch an attack on a website. What am I trying to do in this DDoS attack? I'm trying to overwhelm the capacity of the website, overwhelm it so it can't work anymore. So let's say you've got a website that can handle 5,000 requests per second. Website can handle 5,000. Let's say these things get sent at us at 20,000 requests per second. My web server can only handle 5,000. Web server can't handle all of it. It's basically the service is shut down. That's why they call it a distributed denial of service attack, because it uses lots of computers to take down what you can do. So what do you do about it? You do a lot of things about it. We'll talk, if you guys desire, towards the end, and we'll really talk about the whole architecture. For example, and K1 Arzen, we're definitely going to be using things like Palo Alto and Fortinet. This is not going to be enough for most organizations, or this is not going to be enough for big global organizations. These solutions are good enough for the 80%, but not the top 20%. They're all going to be using Fortinet, Cisco, Palo Alto type things, not cloud native things. And so when we're doing this, if we're going to prevent a DDoS attack, we got to start thinking about a lot of things. One of the things we need to talk about is how do we increase the server capacities as needed. Another thing we need to do is, can we use a service to thwart the attack? So right now we're going to talk about a service to thwart the attack, and if you guys desire, towards the end of the security section, I am more than happy to basically build an entire security policy with every one of you live on the fly for the way you would do it for a global organization, if that's your desire. So what's it all going to look like? How do we use the built-in AWS type of DDoS attack without using all of it, just the DDoS service itself? And then if you guys want, we can talk about the whole thing together. So preventing DDoS is really a full security posture. It's not just using Shield. Using Shield might be 10% of the DDoS protection that you might do, but even that 10% is still a lot. So basically speaking, Shield is a service with AWS, and it can help you stop DDoS attacks. What will happen is it'll block an attack by basically seeing traffic that it doesn't like, and it's going to create like an access list on demand to block specific things. It can create ACLs. You block your unwanted traffic with ACLs, but you can use a security group to protect your servers. And part of it, what you're also going to do, is you're going to use auto-scaling. Now, a lot of times people say, Mike, auto-scaling, I don't understand how auto-scaling helps DDoS. Let's go back to the example I previously gave you. You've got a web server that can only handle 5,000 requests per second. Now you've got 20,000 requests coming in per second. You've got a problem, not enough capacity. Now, what would happen by comparison, just out of curiosity, just for a minute, if your servers auto-scaled? So instead of having one server that could handle 5,000 things, you had 10 servers that could handle 5,000 things because of auto-scaling. Now your capacity is greater than the volume of your attack. So auto-scaling can temporarily help you survive an attack by adding additional compute power. Now, what's the downside of doing this? I'll tell you the downside right now. The downside is, when your systems are going up and auto-scaling, the cost is going to be there. So you can't leave your systems run like this together, because if you were going to try and survive a DDoS attack, you might have an additional 200 servers come up, and that could get real expensive real fast. So firewall helped to block it, network ACLs, security groups, and Shield. AWS provides something called Shield, and it's some DDoS protection services. And there's going to be two versions of Shield. Shield Standard and Shield Advanced. Now, Shield Standard is going to be basic and comes free when you're using WAF. Shield Advanced provides much better DDoS protection, because you can provides protection to EC2 instance, load balancers, CloudFront, Route 53, global accelerators, everything. So Shield Advanced, actually, we're starting to get into some reasonable DDoS protection here. So let's talk about Shield Standard. Shield Standard is free, like I said, when you're using WAF. Shield Standard protects against common DDoS attacks. Think like SYNAC attacks, reflection attacks, HTTP slow read attacks, the big common ones. According to AWS, they say it protects them against 96% of attacks, and that's AWS's numbers. I never take vendor numbers seriously, but 96% is a good number. But vendor numbers, they may or may not be exactly what they are, but still, it's relatively good. And Shield Standard is going to block based upon policy, which means whatever the policy is in it is the best it can do. So Shield Standard, basic DDoS protection, free if you're using WAF. Now when you start getting into Shield Advanced, now you start getting into some enterprise-grade DDoS protection, and Shield Advanced is very different, and you purchase an additional cost. Now you can start protecting your load balancers, your EC2 instances, your CloudFront distributions, and even Route 53. And this is where it gets adaptive. So Shield Standard, planned attacks, things based on policy. Shield Advanced, now you're getting into adaptive or modern security environments where basically it can do things on the fly to figure it out. So if it doesn't like something, it can look, it can change something. It can deploy an ACL on demand. It can do things that mitigate the attack. It's going to give you both visibility, notification, and help to stop these things for layer 3, 4, or 7 attacks. And I actually love this. If you purchase Shield Advanced from AWS, you get access to a 24/7 DDoS team to help get your business back on track, back to normal. Of course, this is only with business or enterprise support options. So, Service Catalog. What is the Service Catalog? It's another one of the AWS security services. The Service Catalog basically helps you control what is placed on the network. How does it do it? It basically creates a list of approved services, or you create a list of approved services, machine images, servers, software, databases, and application architectures. And by doing it, you basically can only pull things out of the Service Catalog. So great way. So I can tell you in my youth, I ran around with a protocol analyzer called the Sniffer, and I was plugging them into span ports of switches, trying to see the kind of traffic that was there. And the reason I did it is I was trying to figure out what stuff existed on the network because none of us knew. And let me tell you, walk into an enterprise, if you ever do this with a protocol analyzer or a sniffer, you will find things that you have no idea that existed and the organization never even knew. So definitely, I'm trying to tell you here, lots of things, lots of opportunities for improvement. And the Service Catalog is a great way to make sure you don't launch things that are not part of the things that have been approved. So wonderful thing. You know, sometimes you see things in the cloud that are just so darn good. Now this is one of them. You go to the catalog, you can pick a list of approved lockdown services. Wow, that's great. Something that's really terrific, wonderful benefit of the cloud. Highly, highly, highly recommend using it. So going back to the Systems Manager Parameter Store, the next thing we'll talk about. And what is this? It's a place. So let's say you've got a lot of passwords, like we all do, a lot of database strings and connection strings, but you need licenses you need to store. Where are you going to put them? You can store them in the Systems Manager Parameter Store. Anything that's critical for you to store secret information, you can store it here. It's a serverless, completely managed environment for storing secret information. Hosted, serverless, that kind of thing. If you've got extremely sensitive information, you can store it here. And if you're going to store it here, encrypt it. You wouldn't store any important information in an unencrypted environment, so you wouldn't do it here either. So in the Systems Manager Parameter Store, that's where you're going to store your secret cryptic information, stuff that you don't want anybody to access to. Now, before I go on to the next section, which is AWS applications, would you guys all like to design a security architecture together, the kind that you would do for a real big bank? If you want to design a security architecture right now, live and on the fly, we will spend the next 10 minutes building a security architecture for a global bank. And if so, say security architecture training in the chat window, and we'll do it together right now. Any questions for me prior? Do you guys want me to design an architecture with you? If not, we can go straight back to certification. So if you say certification, type in the box below, we'll go to there. Otherwise, if you want security architecture, I see Derek Houston, please design the security architecture, which I am totally happy with. I see Rick that's saying security architecture. Pistol grips, yes, yes, yes. Let's do some security architecture training together. Let's have some fun. So let's look at it this way. Let's take your traditional environment. I want you guys to really get what we typically would do in real world. So let's say in real world you've got this. Hold on. So in a traditional environment, let's say you've got the internet, and from the internet is going to be where all your bad stuff is coming in from. So behind your internet, let's do what you need to do. What do you place behind your internet to really keep bad stuff out of your systems? Here's the way you do it. You place this device called a, whoops, that's not what I was looking for. I don't even know what that kind of shape that is. Let's find a shape that I know how to work with. Right behind the internet, you're going to basically have your firewall. And very often, and so where you place your internet-facing router, we can talk about it another time because you could place it before or after the firewall. So let's just pretend that the firewall is less connected to the internet. Right behind the firewall, you're going to put an IDS IPS system. Sorry, I wasn't sharing this. So first you got an internet connection. Then right behind the internet, you're going to have a firewall. The firewall is going to keep bad guys out. So you're going to place a firewall directly behind that. Now, right behind the firewall, we need to capture bad stuff when it occurs. Because we don't want bad stuff happening in our systems. So we're going to place an IDS system. IDS. Oops. And the firewall is going to keep bad guys coming in. The IDS IPS system is going to block everything from coming in that you don't desire coming in. Now we're going to have some DDoS protection. And this is going to stop any DDoS attacks. Now at this point, we've protected the traffic that's coming into our VPC. We basically have a soldier sitting there, or a knight that's there and ready to basically stop any attackers getting in. We've got a DDoS protection that's going to do something like this. And now after the DDoS protection, and what we're ultimately going to do is we're going to use an access control list to protect the subnet. So we're going to call it a network ACL. Because on AWS it's called the network ACL. Now, that's still not enough. Now what we're going to do is we're going to make now we've got the servers, right? So on the servers, we're going to use a security group. Do you guys think that's enough? Nope. Why is it not enough? Because things happen. So in addition to the security group, which is a host-based firewall, it might make sense to actually install a host-based firewall software as well. On top of that, as a second layer of protection, host-based firewall. You might also want to do malware protection. What else do you do on the server? You're going to harden the server. How do you harden the server? You disable all services that are unnecessary, and you patch it with the most up-to-date security patches. That's what you do next. Do you think this is enough? No, of course not. Now you need to control who can access the systems. Now, realistically speaking, on your network side, you're going to limit who has routing information to what subnets, because if you don't have a route to it, you can't hack it. That's going to be a lot more challenging things than I can architecturally draw here. But what we'll talk about, but we'll actually know what we can still do. So let's do this. So let's just build this thing. I want it to really make sense. So over here, we're going to have a strong IAM policy, because this goes into security, determining who's allowed access to what systems. And that's how we would do this. So we'd have a strong IAM policy. Oops. Then after we had a strong IAM, and then after we would do IAM, we would make sure we would encrypt our data. To make sure that if our data was stolen or the RAID arrays were taken away. And this, realistically speaking, are the kind of things that go into it. So, and also, if we wanted to protect against DDoS, we'd have auto-scaling. This is the majority of what you would typically find here, along with the principle of least privilege to make sure that you don't give access to the wrong people, making sure your operatings are secure, making sure you don't have systems on your network that you don't know about. These are the kind of things that you would do when you would design a security architecture. It's a combination of all these things, as well as some adaptive things which as well. But this is your primary security architecture. This is how big global enterprises. This is how banks, global retailers, high security environments across the world lock down their systems, and this is what we recommend doing. This is the way these things kind of work. So that's how we typically do these things. So now that we've talked about how to lock down your systems, we still have about a half an hour for which I can cover some AWS services, and we need to do that if we want to finish up tomorrow afternoon. So before I do that, any quick questions on the security architecture? Waiting a few seconds because there's a lot of things on this next list of things that I want to cover, and I want to make sure we do it. Okay, I don't see any questions, so I'm going to get back to training and try and make this as interactive as a time. If you guys are having a good time, if you're enjoying it, if you don't mind leaving a like and or sharing this video with others, it helps our channel grow. My team also has informed me before I go back that I should put a link to our program to help you get your first cloud architect job, as well as a coupon code to do it. So let me paste that in according to my team, because they've been letting me know I'm supposed to do these things, and we'll get back to the training. So in this section, what we're going to talk about are the AWS services. And this is SQS, SNS, SWF, Elastic MapReduce, Kinesis, ECS, EKS, Elastic Beanstalk, CloudTrail, Config, CloudFront, Lambda, step functions. We'll talk about recognition, CloudFormation templates, and certificate manager. And load balancers do not increase security, so they're part of an availability and performance, but not really a security. So we would use this as part of the web thing with regards to help scaling out and add instances, for example, which should help with DDoS. But it's not really a load balancer. Is not a security appliance. It's a performance appliance. So I listed the security appliance certificate. So I listed a large number of AWS services. So let's start talking about them. The first service that we're going to talk about is Amazon or AWS SQS, Simple Queuing Service. Simple Queuing Service is a very elegant solution. It is a queuing system designed to help you decouple your application architectures. You could see that in a question. SQS helps you decouple application architectures. What does it do? It segments and decouples things. It's a place for you it's an intermediate stop for messages on their ultimate way to destination. Now, organizations have always used queuing systems. When organizations have used queuing systems, the way it works is they had to custom design it. But in this particular environment, they don't have to custom design it. Why do they not have to custom design it? Quite frankly, for the following reason. Amazon basically made it. So SQS is a pre-made message queuing service from AWS. SQS provides some temporary storage for your messages. So here's the way it's typically done. You got your web application, you've got your web application. On the way to the database, you stick an SQS queue. And that way, if the database is busy and the messages on the way to the database don't get stuck. But you can use your SQS queue for lots of places. It just decouples your application architecture. So it's a message queuing service that's going to provide temporary storage for your messages on the way to their destination. SQS is going to enhance your application availability by providing a means to keep your data services from getting lost. SQS will give you a transient place to put your messages, and they can stay there for a while. Typically speaking, 4 days all the way to 14 days, but the default retention period is 4 days. Look at it this way. Messages coming into your ordering system into way to your database. If your database is busy, they got 4 days to 14 days to get there, so you don't lose the order. What a great way to improve your scalability. Some things in the cloud are just so simple and elegant, and SQS is one of them. SQS enables you to right-size your applications. Why? Because if you didn't have SQS, you'd have to overbuild for peak. With SQS, you can smooth it out to what you need at the time. So SQS is brilliant. SQS facilitates auto-scaling, and SQS really mitigates the need for you to custom develop your own kind of thing. So it's pretty awesome. So let's look about the way you would typically use something like this. You would typically have a web server, and you'd have an app server, and you'd stick SQS along the way to basically this ultimate destination. So SQS, great way to improve the scalability and performance of your systems, enables you to right-size your systems, and it's terrific. Now, when you're dealing with SQS, you've got a couple opportunities. You've got the ability to use a standard queue or a FIFO queue, and they both have their advantages. The way SQS typically works is messages come in and messages come out as fast as possible. And because they come in as fast as possible, realistically speaking, I'm having some internet bandwidth challenges here, so I'm trying to reduce my bandwidth consumption real quickly. So bear with me for a second. I saw my screen freeze, so I'm going to try and shut down some connections I had going on to the internet that were busy doing things. So with SQS, you basically can set up a standard queue, which means messages come in and come out as fast as possible. And also, in addition to coming in and coming out as fast as possible, the way these messages work is you can send them in first in and first out. But there are lots of challenges associated with first in and first out. So we can talk about what they are. But let's first talk about the standard queue. Messages come in, they come out as fast as possible. Every message is going to be delivered at least once. But they might be delivered out of order. The messages are going to be delivered as fast as they can. So if you've got small messages, they may get through faster than bigger messages. If your applications can tolerate this, this is your best option. This is your best option if and when your applications can tolerate messages being delivered out of order. So if that's the case for you, that's definitely what you want to actually be using, a standard queue. Now, if your applications cannot tolerate messages being delivered out of order and they need to be delivered into certain things, then you can set up what's called a FIFO queue, meaning message 1 comes out, message 2 comes out, message 3 comes out, message 4 comes out. Now, if you do this, it's going to slow the system down. Because if you've got a huge second message and a small third message, the small third message is going to be waiting behind the second message. But that's okay. Because if you design this way and your applications require this, this is what you do. You design based upon business requirements. Design based upon application requirements. That's what goes into the job banking architecture. So if you need first in, first out, you use it. Now when you do this, there's a good guarantee that your messages come and pulled. So it's reliable delivery. And since they're sent and received, and you know where they're going, you've got a lot of confirmation and reliability. So first in, first out, guarantees message order. Standard queue, fastest possible things. Choose what you need. How does SQS work? Message goes from the computing platform to the queue. After the queue, it gets scheduled for delivery, and if the ultimate destination is busy, it stays into the queue. When the message comes out of the queue when it's ready to be delivered, and that's it. So let's look at it in one more graphical representation. Sender says a message, goes to the queue, gets delivered to the receiver, and you can see it gets drained from the queue, so the message is no longer sitting in the queue. That's the way SQS works. It looks like my internet bandwidth cleared up. So when do you use SQS? You use SQS to assist with capacity planning, to make sure messages are not lost, to make sure you optimize your costs. And here's where it gets cool. You can use SQS to optimize and scale auto-scaling. What do I mean by that? Let's say you've got a lot of messages in the queue. You can look at the message queue depth and tell auto-scaling, kick in, add extra compute instances because we're busy and we need this queue to be drained. Very cool, very cool. This is the part of the benefits of the cloud. When we talk about the cloud and we say there's some performance limitations on some things, but some things become extra elegant and simple, this is what we're talking about. This is exactly everything we're looking for. Wonderful, wonderful, wonderful. Auto-scaling based upon message depth in the queue. Now think about it this way. Typically speaking, if we're going to use auto-scaling, we're going to set a policy memory is busy or CPU is busy. That's it's a proxy for what's going on in our systems. Message depth tells us exactly when we need to scale. So this is the perfect way to do this. It also scales your databases by reducing write load. So when you're dealing with database scalability, you're often using these things for reducing write load. Well, we've covered SQS. Now there's another system, not SQS, called SNS. And people get confused here, so we don't want you confused. SQS is used for queuing. Message stop, guaranteed message delivery. SQS is used for queuing. SNS is used for notifications and messaging. So now that we covered SQS or queuing service, now we're going to cover SNS or simple notification services. And this is basically a message service to send messages in between systems. It's used to decouple messages between microservice applications. It's used to send emails and SMS messages to mobile devices. It facilitates communication. The way it sets up is basically there's publishers and subscribers. Subscribers, basically, it's like joining a mailing list. They subscribe, and then when the publisher pushes notifications, they get notified. So that's what NSS does. It's a notification and a messaging service. I mentioned publishers push, subscribers receive. Think of it like a mailing list. Now let's look at what it realistically means. So you've got your publisher, it sends a message to a topic, and the topic can be there. Now this is called something called fanning out. And you may hear that SNS is used to fan out things on your AWS Certified Solutions Architect Professional exam. And if you do, what fan out means is it can take a message and it can deliver it to a lot of different locations. For example, you can have a message that gets delivered to a queue, also kicks in a Lambda function, sends an email, and does something else. Fanning out, taking a message and sending it to multiple locations, that is what Amazon SNS does. Simple, elegant way of the way it's supposed to be. So let's talk about SNS some more. SNS is basically a high availability messaging service that's pre-made, meaning you don't have to make it. Used to fan out messages, like I said, to large subscriber systems, endpoints, SQS queues, Lambda functions. It enables you to create filter policies so you only receive notifications that you want. And what a great way to be notified of systems and challenges. So let's talk about some use cases. Common use cases include, you can set up an SNS message when your CPU hits 80%, for example, and notify systems admins, or when a predefined event occurs. You can fan out message. You can take a single message, basically an order's placed, send a message to SQS to start working on the order, send a Lambda function to kick off something, notify somebody with an email, order's been received. It's often used for mobile notifications because SNS can push notifications directly to your phone. Basically, let's say you're a store and you say flash sale and you want everybody to know about it. That's what this thing is done for. Let's talk about the next AWS service called Simple Workflow Solution. Let's say you've got a multi-step process. Process 1, Process 2, Process 3, Process 4. If you can set up a system where basically you do step 1, followed by step 2, followed by step 3, you do step 4. So your manufacturing basically requires the frame of a car to be built, the body to be put on, it be painted, and then, washed. Each step along the way. So you create a workflow of each step that has to happen, and this can save you substantial time because it can remove the manual intervention and help automate things. So here's a typical case. I spend a lot of time with video, so let's use a video scenario that I created specifically for this. Let's say I upload a video, and then the video gets web optimized, meaning it takes raw video and it compresses it down using like an H.265 codec, for example, and then it gets sent to a transcription service to transcribe it, and then we burn in the captions in another thing, and then we basically send the video after it's been fully processed to an S3 bucket, and then after that you send me an email that says, Mike, download your video. Realistically speaking, that's what Simple Workflow is for. It's simple, it's elegant, it's pre-made, and it can save you a tremendous amount of time. And this is one of those things where some of these cloud services are just so good, they can save you substantial time, effort, and money, because you don't have to build these things. They're already pre-made for you. And when you don't have to build your own, you can save it substantially in development costs and things like that. Look at it this way. As you start exploring futures and careers, if all this stuff is pre-built for you, there's probably a lot less opportunities in software development than there are in system design. That's why I like architecture. Plus, I also like to do things that most people don't do, because as a rule, the laws of supply and demand and economics come into play. If everybody's taught programming in school, there's a lot less opportunities for programmers than people that are taught cloud computing, which is basically nobody. So have a valuable skill set, have a skill set that's in demand, and have a skill set that nobody knows. That is your ticket to career success. Architecture is something that very few people in the world actually understand, except for those of us that have done it for a while, which is why I like to talk about it so much. Why do I like cloud architecture? Because this stuff is pre-built. So you don't need to have as many software developers in your team. Because you need to have less software developers in your team, it's faster, more efficient, and costs less. So just think about that. The next service we're going to talk about is basically we're talking about databases and things like that. So let's say you've got a lot of information, Organizations collect lots of information. Organizations collect large amounts of information for the following reasons. They want to do something with this information. They want to analyze this information. They want to make better decisions with this information. That's why organizations collect large amounts of information. So what do they do with this information? How do they get it? Well, another tool that AWS provides you is something called Elastic MapReduce. And that's an application that's really used to process and analyze large volumes of data. It's a managed cluster, and it's basically part of your big data framework. Again, it's another one of these pre-built data analysis tools. One of these things about the cloud is so much of this stuff is already developed for you, so you don't have to develop it. So there's no server management, application selection. When you start looking at this EMR, what's it built on? It's built on these big data tools. Apache Spark, Apache Hive, Apache HBase, Apache Flink, Apache Hudo, and Presto. So these are kind of things, offers great performance, and it's less expensive because there's no management and there's no coding required. Anytime you can get out of coding, you can dramatically reduce the cost of your systems and your services. So what does the Elastic MapReduce look like? Basically, you take your input of information, you reduce it to something valuable, and then you output it. Now at this point, we've got 12 minutes left to go. So if we've got 12 minutes left to go, I think we should open it for last minute questions, and then we'll resume tomorrow with the remainder of the services, and we'll get you guys finished up. I've got until 2:58 before I have to join the next call that I'm leading with my students, where we're going to be designing big architectures, and we're all excited because we have some people from AWS that are interested in talking to my students to become employees. So can't stay late today because I've got a lot of students that are waiting and excited to meet with AWS. But do you guys have any questions prior to us moving on for the day? Any last minute questions for me? Any last minute questions for me? Tamla, great question. Use case from EMR? Big data. Lots of data, lots of analysis to do of your data. Sarkan, I have honestly no idea what you mean to understand what better, DB query, email, etc. If you're more clear, I'm happy to help you. Erika, how could Cloudflare protect DNS? You can protect against DNS via a lot of things. Basically with DNS, you could basically block things that don't look like good requests. Content delivery networks don't pass bad requests through. Content delivery networks also provide a caching typical service. So what the content delivery networks do on this DDoS protection is it looks for a bunch of ridiculous requests, like TCP sends that don't match, or SYNAC attacks, or pings of death. It looks for large sizes of files and things that don't look normal, and then what they do is they start blocking things because they view it as a policy that violates what standard things is. So that's how. Taye, thank you so much for the GCA. We appreciate it. We really appreciate every one of our students that are here. What services can be used for IDS, IPS, and AWS? Akaboom, that's a great question. What you have to do is you have to go to the marketplace and you have to get something from, say, Palo Alto or Cisco or Juniper or somebody that can do that. Because there's nothing that AWS provides that actually does that by nature. Shield Advanced gives you a little DDoS and a little bit of like IDS, IPS protections, but it's not specifically DDoS protections. It's not specifically an IDS system like the other things that we're talking about. It's similar in a lot of ways, but different. Oh, Sir Ken, I think I might possibly understand what you're asking. So SQS can handle pretty much any kind of message you want. That's the point. If it's basically a message going into your database, it's a pre-built queuing service that you can use it for whatever kind of messages you desire. That's how it's going to make your life easier. So so whether it's HTTP, HTTPS, a database request, it's going to deal with all of it. Any other last minute questions? Thank you, Vikas. I deeply, deeply appreciate your kind feedback there. What is SQS queuing? It's a great question. SQS, or simple message queuing, is a means for you to drop off your messages along the way to the route to their destination. Oh, now you okay. Absolutely. From my team, if you've not completed the form, please let us know. We really like to know where you find us from, so we know how the best places to deliver you content. And if you've got any questions about our training or how to get your first cloud architect job, let us know. What I'm going to do is I'm going to provide a couple of free links for you all today. First, I'll provide a link to our course and a coupon code to it. Next, what I'm going to do is, if you're curious on how to get your first cloud architect job, we have a free webinar that we do twice per week. And on this free webinar, we do a lot of really cool things. What we do is we tell you everything that's necessary to help you to get your first job. We'll tell you our process, which you can use on your own. We tell you our methodology, which you can use ours or you can use on your own. And we will tell you how to get hired. The other thing that we're going to do next Tuesday, if any of you desire, we are going to have another Cloud Architect Career Challenge where we're going to invite people from all over around the globe to one of our challenges. You will interview me. I will give you a very deep, complicated architectural challenge. And the people in the room will design an architecture on the fly with my leading you and my coaching you. So the links that I've given you are the training programs that we do. I've given you a link to the free Cloud Architect job webinar where we teach you how to get hired. And then we teach you how to work for the, and we also teach you, what's the word I'm looking for? How to design things in an architectural class. And we do it all for free. Obviously, our internal students get about 10 times more than we do for free, but we try and still provide the best free training we can on the internet. So, a kaboom, it was wonderful to be there with you. Tai, I'm so excited to start working with you. And anybody that has any questions for me, I'm going to do this. I'm going to leave my phone number. Yes, guard duty does a little of these things to but nothing with regards to what I'm referring to with regards to a full enterprise security solution. And that has to come from the marketplace. Thank you all. It's been a real privilege to spend some time with you today. If you can all give a like and a comment and subscribe and hit the bell if this is interesting content to you. And we're going to be doing a lot more free training and a lot of network training people ask me to do. And I might even do a full AWS Advanced Networking course in the next 30 days if you guys are interested. And if you guys are interested, I might do a complete free AWS Advanced Networking Bootcamp on the cloud. If that's a desire, type AWS Advanced Networking, please, in the comment box before I close the window for today. In case of any questions, some people are asking me for the link to today's sessions, so I'm going to just send it to some of my students while we're waiting to see if any of you guys have any last questions. Okay, it looks like you guys are signing off, which just totally makes sense. Thank you all. Again, it's been a real privilege to spend some time with you. Really appreciate everything, and I will see you all very soon. Pistol Grips Vlogs. In order to attend that webinar, just click one of those links that I sent you, and you will be able to join the webinar, register. And Vikas, if I got one vote for AWS Advanced Networking, if I get enough, I will do like a 3 to 5 day AWS Advanced Networking bootcamp just like this. Again, tomorrow we're going to have hopefully what's going to be the last day of this bootcamp. If we can't finish it all tomorrow, we'll do it on Sunday, but hope to finish it all tomorrow. I want to make sure you all have a wonderful, wonderful, wonderful experience. Perfect. Thank you so much, and we'll catch up to you soon. Take care, everybody. See you all tomorrow.